Hello, everyone, and welcome to our Tech Days Putting the Ops into DevOps. We're going to be live in just a few moments' time. So if you're watching live, go and make that last minute cup of tea. Oh, and I've got a wonderful echo on the line, so that was a great start. We're going to be joined in 5 minutes, so go and make that last minute cup of tea. If you're watching on demand, then scoot forward 5 minutes, and we'll see you at the top of the hour.
Hello everyone, and welcome to our event today, Putting the Ops in DevOps. My name is April Edwards, and I'm going to be your host throughout this entire event. We're here online today joining you with some of the best experts in the industry to help you as an IT pro get started on that DevOps journey. So before we get started, we have a little bit of housekeeping. We're going to go ahead and reference our code of conduct that we run for all of our events. Please ask any and all questions in the chat because we want to hear from you and we want to help you. We want to answer your questions as we go along. So let's meet who our speakers are going to be in this event. I've already introduced myself. I am April Edwards. I'm a senior cloud developer advocate and they're all here local to you in the UK. So what is already done? I'm going to introduce you to some DevOps topics and some principles to get started. First up on our speaker list, we have Esther Bartel. She's going to talk to us why ops teams should even care about DevOps and why we should invest in it, and all these amazing benefits that it will bring. Then I'll be joining John Lunn, and we're going to talk about continuous integration and continuous deployment. And we're going to break down all these functional components so you can understand them and take that away with you. Then the last session of the day, we have Barbara, who's going to walk us through actually setting up our pipelines, and you can practice alongside with her. And at the end of the session, we're going to open this up for Q&A. So please, please, please ask questions as we're going along. All the speakers will be behind the scenes answering those questions for you. And at the end, we're going to have a very interactive Q&A session where you can literally ask us any question you want. So please do. So let's get started. Why do we care about DevOps? First off, I want to level set. I want to give you the definition that we use to define DevOps here at Microsoft, because the reality is all of us have different backgrounds, right? Some of us have no experience in DevOps, and some of us see our developer teams working with it or other teams in our organization. And that kind of derives our experiences in how we define DevOps. But I want to level set. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. I want to focus on this word value because it doesn't matter what we're delivering to our organization or to our end users. Are we delivering value? So if we think of how our teams are structured today, as an IT pro working in the operational space, you're incentivized to keep those lights on 24/7 by 365. Your developer teams are incentivized to develop new features. And those two things naturally kind of develop these silos in our organizations because we're not incentivized to deliver that same value to our organization. Because as our developers deploy those new features, as an IT pro, we're really nervous they're going to bring down our infrastructure and it might cause an outage. So we need to align these values in our organization, and we need to look at how we deliver, what we deliver, and bring our teams together. We need to enhance our productivity in our teams, and we need to facilitate experimentation and develop this growth mindset so we can all explore and we can all learn. So why is DevOps important? Well, because your competition's already doing it. We think of all those organizations out there that are doing great things in the industry. You know, let's think about lockdown. How many of us ordered a Domino's pizza? I ordered many. When we order Domino's pizza, we know from beginning to end where our pizza is and when it's going to get delivered to our front door. Also Netflix. These are all high-performing DevOps organizations. But the biggest reason why DevOps is really important is to reduce human error. So we talk about DevOps as a theory, but it's actually a practice with hard statistical figures. Now, as an IT pro, we've all been there. We've made a change in our organization to our environments, and we've brought something down. The reality is our organizations want things delivered yesterday. We need a faster time to market, and honestly, our organizations want to see an increased revenue. So this is a fact of DevOps. We have hard stats because we're tracing everything from beginning to end. So high-performing DevOps organization deploy more frequently, whether that's using infrastructure as code, automation, etc. And they have over 100 times faster time from commit to deploy. And this is important because we include testing in our life cycles, in our code, in our infrastructure as code. And using this word code is new as an IT pro, but we're going to make you more comfortable with this word code by the end of this session. We also need to be able to recover from incidences faster. How many of you have had an outage in your organization and then you have to trace that whole thing back to find out who did it? There's usually a lot of blame pointing and a lot of upset. But if we can recover from an incident faster, because we're all going to have incidences, that's really key to the organization, and that's delivering value. I want to talk a little bit about vulnerabilities in our organization. And I want to talk about the cloud. So 95% of cloud breaches occurred due to human error, which is one of our biggest reasons to envelop a DevOps mindset in our organizations. We could do something from misconfiguring a firewall. We could leave a plain text password. When these breaches occur, they cost us millions and millions of dollars or pounds or euros in recovery. And we also know that when we fix things in production, it costs a lot more than in the development phase. And that's why looking at ways to do things early and often in our processes is absolutely advantageous to us as an organization. We need to start secure and stay secure. So I'm going to give you a couple examples of organizations that have had some breaches. So I'm going to talk about Uber. Yes, they're a high-performing DevOps organization. They still make mistakes. Uber actually had a plain text password stored in their repository where all their code sits. Someone got into that repository, got into that plain text password, and caused the breach. That cost Uber millions and millions of dollars and exposed really crucial customer data. Again, a human error. But I want to ask you out there, how many times have we been delivering a project where we've rushed things and left that password somewhere in a file we'll do later? Like, oh, we'll just leave it over here. I've done it. I've left it on a plain text password on a server and somewhere maybe no one will find it, but someone will find it. We need to look at ways to secure our code. We need to patch our infrastructure. We need to continuously stay on top of these things. And that's really hard and it takes a lot of time out. So I want to talk about two different types of deployments. First is the epic deployment. And we've all been there. These are big monolithic applications and infrastructure. These are complex environments where we have all this domain knowledge that we've built up over time. They're complex, they're stressful, but we need to update the system. And we run updates probably once every 6 months in our epic deployment. And when we do this epic deployment, it's an all hands on deck situation, meaning you and all your subject matter experts are there and ready to go. Now, we know we have to take our services offline. We got to update some infrastructure. We got to update our applications. But this code was written 6 months ago, and we have to update our infrastructure from the last 6 months. Because we're doing this big monolithic update, things usually go wrong, and it doesn't go very well. And this isn't reproducible. So every time we do this big monolithic epic deployment, we have to kind of reinvent that wheel every time. We really want to move away from this mindset and think about a continuous delivery model because we can and we should do better. So looking at the continuous delivery model, we want to deploy more often and in smaller, more focused changes. We want to deploy things such as software and even things like infrastructure as code in small, immutable changes, which are really important. Deployments can happen often, whether that's daily, hourly, or monthly. It's a huge improvement over that monolithic, epic deployment. And we want to test our deployments end to end, so we know what we're doing before we do it. Now, as an IT pro, testing your code, or in fact, writing code is really hard, right? Or maybe it might be really new to you. You have to learn maybe a new language. So you can do these things in PowerShell, but we're going to talk about Bicep and Terraform in this series of different types of infrastructure as code that are available to you. So you have to pick the language that's right for you, but then be able to test it so we know what's going to happen before it deploys. Because again, we hit that big red button and we don't know what's going to happen a lot of the times. So we want to move to that continuous delivery model where we test things end to end, we can deliver it, and we have historical records to understand where things went wrong. So if we have a deployment pipeline in this continuous delivery model, we can see what went wrong where, and we don't have to go to production every single time. So these are really important concepts. Now we're going to dive deeper into each of these in the upcoming sessions. So we're going to kick off with our very first session now with Esther Bartel, who's going to introduce all these really important things that make up this DevOps delivery model for you as the IT pro. So let's kick it off to Esther.
Thank you very much for that nice introduction, April. And hello, Microsoft Tech Days. Let's dive directly into DevOps and all the coolness that I get to share with you today. If we're looking at DevOps, I think it's best to start with the definition of it, which basically says it's a set of practices that combine software development and IT operations. And I have to admit, when I first read that definition, it didn't tell me a lot of details on what to expect for DevOps. So for me, it was very important to understand where basically I have to position DevOps. Is it more sitting on the ops side or is it more sitting on the dev side? And for me, I felt it definitely leans more towards the development side. I have at least about 30 minutes to show you what it's all about. First of all, I wanted to share this tweet from Aaron Parker, one of my fellow MVPs, who basically shouted out at Twitter that we are becoming developers. And I do understand that sentiment, because sometimes it does feel, if you're transitioning to a DevOps engineering role, it does feel like it's more about development than operations. But I have to admit, even before I could respond to his tweet, Tobias did a very well response before I was done typing my message. And what I loved about his message is that he basically says, we've been automating processes and repetitive tasks all our lives, or all our IT working lives. And I have to agree with him. But what struck me most about his message is that he says we now have better tools. And I think that definitely applies if we're talking about DevOps. I also understand the better tools is also a lot more tools. So please do not be overwhelmed, as I was, by this enormous amount of tools that is available. Because I think if you really want to understand DevOps, it's not about immediately focusing on the tools, but first of all, look at the different processes and methods that are available if we're talking about DevOps. One of the things that I had applied during most of my career is doing projects with a waterfall method. And if you're looking at the waterfall method, you clearly see that it has three very clear phases. First of all, we create a full blueprint of our solution. And then if we have all the what-if scenarios covered in our blueprint, and we have that full-blown picture of how to implement the solution, we start to build it. And then after we finalize the build phase, it's all about releasing. And that's where the end user comes in place. And basically, that's the first moment that we're getting feedback on everything we build. If we're looking at the agile way of working, which definitely is a better approach if we're talking about DevOps, it's all about shorter cycles. So you still have to define and build and release. But as you can see in the top of this picture, is that with Agile, you have way more moments, first of all, to focus really on a subset of features. So that makes it easier to focus on that part of your solution. And you also have multiple release moments where you get feedback from your end users, which makes it easier to adjust if you discover that you're not fully aligned with their expectations. To make it a bit more visual, I usually use these, I'm not sure if this dates me, because some of you might recognize these pictures from very old trainings that we had in the past regarding project management and talking about functional requirements. But for me, this is a nice way of visualizing with Waterfall that basically in the end, when you get your feedback, you only have a moment to tweak and to get those workarounds for the feature set that is not right there yet. If we're looking at Agile, definitely that first release is not the full feature set, but it does allow you to swing from a tree. One of the things that you see is that now already security can get involved in this one and give you some feedback on the fact that it might not be clear to all end users which body part to put in that strict to basically start swinging. So it does make sense to get that feedback incorporated, and with your next iteration, with your next release, come up with an improved and more secure solution, as you can see in the iteration 2. And if you keep doing that and keep tweaking until you have all the functional requirements in place, what you see is that you get a very comfortable swing that I would definitely love to use as an end user. If we're talking about Agile and Scrum, we also need to talk about the fact that it does require a change in the way we used to work. especially coming from an operations background, where it's a lot about focusing on keeping your production environment very stable and a lot of ticketing systems that require you to focus on a reactive approach on improving your solutions. If we're talking about Agile and Scrum, I think it's very important to understand that it's not just one role in that DevOps team. It's not just one DevOps engineer or one type of role within a team. So as you hopefully can see, there are multiple roles within that team, and you have that product owner and Scrum Master to facilitate your process and make it very easy for you to focus on the work. What I love about the DevOps team approach is that we have this shared responsibility to make that solution the best that it can be. And I love the fact that it's all about being a cross-functional team. So you don't have to focus on just one expertise, but it allows you to share knowledge with your other team members in a more T-shaped way of building your own competences and extending your own knowledge. Big part of working in a Scrum team or in an Agile way is the daily Scrum. And I have to admit, when I first was joining these daily Scrums, it kind of felt like this kumbaya moment where we're sitting around the campfire, singing songs, sharing all these amazing stories of all the adventures we experienced yesterday and what adventures we're gonna continue to explore today. But for me, personally, I discovered that I'm not very good at asking for help. So that daily Scrum is a great opportunity for me to talk about what's in my way or my impediments or the challenges that I'm facing and I haven't conquered yet. And it allows this opportunity within the team to offer help, because now I just have to describe the challenges that I'm facing, and it offers this a window of opportunity for the other team members to tell them that they might have experienced the same and they might already have a solution for what I'm facing. So definitely embrace the daily Scrum and see it as an opportunity to offer help or to ask for help in a not very asking way, so to speak. The main focus, if we're talking about DevOps and operations, is all about infrastructure as code. If we're looking once again at the definition, it states that it's a process of provisioning infrastructure resources similar to how software is deployed. And basically that means that we're using a lot of templates and scripts together with an orchestration to deploy our resources either in an on-premises cloud environment, private cloud, or maybe even a public cloud environment. And to make it more accessible, let's use a very common and basic example for infrastructure as code. What you're seeing here is the interface nowadays of the Azure portal for creating a storage account, which to me felt like a nice hello infrastructure as code example. If we're looking at the steps that you have to go through manually through the portal and compare that with an automated way of doing those same steps, building a template, creating a script for the deployment based on that template, then you'll quickly notice that there are some differences that we need to take into account. So let's check out this face-off video of both methods. And I fast forwarded it because it didn't feel right to just stare at the screen and follow exactly each and every step. But this is to show you basically how quickly the different approaches deal with the same example. So what you're seeing in the portal, I have to go through all these different tabs, enter the data, and then hit that create button to start the deployment process. On the other side, in the automation, it's all about entering that template, because I wanted to make it a fair comparison. So you have to create that template, you have to write that script for the deployment, and then what you're seeing now is that we're finally entering that deployment phase where the resources are created in Azure. So I don't know about you, but this kind of feels like not the best argument to start automating. But what I wanted you to realize is that automating everything is not instantly the best solution. You have to be prepared to look at the different phases and the different processes that you want to automate and see if you can get an advantage in automating it. As you can see, the portal is a lot faster than creating that automated deployment way with infrastructure as code. But what I love about infrastructure as code is the reuse of what you created for the automated process. With templates, it becomes easier to reuse by just tweaking some of the input parameters, like creating a new storage name, specifying different settings for that storage account, by just instantly tweaking some of the settings of that template. So if we're looking at the reusability of that template versus the manual actions in the portal, it might become a different contest or a different end result. Because with the portal, we still have to go through each and every tab again, because we cannot reuse that information as easily as running that script. And what you're now seeing is with infrastructure as code, definitely we have a faster way to deploy in a very consistent way. And the reason why we're promoting this automated deployment is that it also allows you to incorporate continuous integration and continuous delivery, which nowadays is becoming the new de facto standard for fast deployments and keeping up with the many changes that are now happening in software development. Another thing that you already heard me explain or mention a lot is code. So to really understand what type of coding I'm talking about, I think it's very important to explain imperative versus declarative code. If we're looking at imperative code, it's all about executing a sequence of commands in a specific order. Kind of like following a step-by-step instruction manual, like a recipe for creating your own burger. And that already starts with all the ingredients to create your own barbecue sauce and how to make sure that you spice up the meat. And then, of course, building that bun, making sure that you have all the layers correctly faced up. If we compare this to code, it's all about scripts. Because if I, for instance, look at my favorite scripting language, PowerShell, it's all about creating those step-by-step instructions translated in an automated way. On the other hand, nowadays, what's becoming more and more popular is declarative code. This is where you specify basically only the end configuration that you strive for. It feels like ordering from a menu. I can just look at the different options that I have, select the hamburger that meets my expectations, and then I don't have to worry about how it is prepared in the kitchen. I can just sit there, wait for the end result, my end configuration of that burger to be delivered, and then I can already enjoy it. And the cool part about using declarative code is that you can still specify, in case of this burger, whether or not you want that tomato on the bun, or maybe even want your hamburger to be medium rare prepared. Translating that back to code, I'm talking about using templates. As you already saw in the video a minute ago, templates allow me to specify that end configuration that I strive for. In this case, I'm using Bicep as my template language to build basically that definition for the storage account. If we're using a lot of code, I don't know how you handled keeping your code in a centralized place. From my operations days, at least if we're talking about code and storing it, nowadays with DevOps, we're talking about source control. And source control is all about managing those changes in your code by making sure that it's timestamped and it can be traced back to the author. So basically, it means an evolution in how you store your code in a centralized way. Because I don't know about you, but I used to timestamp each and every file by adding that date into the file. And then I had all these different variations where I started to add updated to it to make sure that I understood that that was like the latest version. But of course, also with bug fixing and everything, even that latest version didn't always work and had to be fixed and edited. So this gives me a very unclear list of a lot of files that doesn't really specify which one is working and which one isn't. And the cool part about using source control is that it allows you to just focus on that one file, and you don't have to be scared of changing it because it might not work after your changes. Because you can easily revert back to that time-stamped commitment that you did previously, or you can just accept those changes and make sure that that becomes the new production version. But I'm pretty sure John can tell you a lot more about using source control and how it works. Or maybe we can even ask Barbara to show us a bit more about the mechanisms. The last thing that I wanted to share with you, which I think is a very important method to keep the conversation within the team going, is to look at workflows. For me, workflows or process flows help me in making sure that the discussion within the team on the feature set that we're working on is at a functional level. And it also allows for everyone, regardless of how experienced you are with scripting or with other tools that you are using for your automated deployments, to still contribute to the conversation of that functionality that you're building. So in this case, going back to that example of creating a storage account, it is just 3 simple steps that I specified, or 3 simple tasks that I specified in my workflow. First of all, logging into Azure, making sure that I am authenticated, then creating a resource group, because each storage account needs to exist within a resource group, and then create that storage account. So it's just a couple of simple steps, but by defining that in a workflow, it becomes clear what the sequence is, and it also becomes clear what input is required and what output will be delivered by each and every process step. And then you can easily translate that workflow into defining the different tools that you need to use for the implementation. And then have different team members use maybe even different methods or different tools to implement each and every step. And at the end, make sure that you merge all those codes changes in your end result, and make sure that you test that everything works accordingly. So now that you have an idea of how workflows can help you in that conversation on functionality and making sure that each and every team member is aligned, we can definitely dive into pipelines. But I have to be very honest with you. Unfortunately, I think my time's up. And even though I would love to talk for hours about pipelines and how you can implement each and every step in that, I will just give you a quick rundown, and then we'll hand it off to John for sure. So just going back to that workflow, that's your base. So if you already have that workflow worked out at that functional level, it becomes very easy to translate that into the pipeline workflow that you need. And the other things that you need to make sure that you get interested in is how these triggers and events work. And last but not least, understand that we have this huge marketplace that gives us already so many built-in tasks or custom tasks that you can easily reuse and incorporate within that workflow, within your pipeline. And with that said, all I have left is to say thank you. I'll make sure to check out any questions that you might have within the chat and join you there. And then I guess, John, you're up. And I'm looking forward to learning even more about pipelines from you.
Welcome to the second session for Putting the Ops in DevOps. I'm here joined by John Lunn, who's a very close friend, and he's an amazing Microsoft MVP who has lived and breathed the transformation to DevOps. So John, tell us, what triggered it, how did it happen, and then you're going to talk us through some really cool pipelines.
Yeah, no, absolutely. Well, firstly, thanks for having me here, April. It's a pleasure, really excited to get into this topic area. So yeah, I guess I've been working in the IT industry for a number of years now, and like us all in the IT pro space, we've kind of lived and breathed infrastructure over the years with application deployment, with feeding and watering and keeping the lights on essentially for our IT applications and business applications. When it came to learning the tools of the trade in terms of what Azure DevOps or DevOps is all about in the space that we live in today with cloud technologies, it really is a transition for an IT pro to kind of take the knowledge that they've had with the applications into that arena and kind of use that tool set for the greater good. So yeah, we'll jump on in, and I've got a few slides that I want to talk you through and kind of bounce off you, April, really, just to get your take on things and hopefully help our audience understand how they could kind of bring these tool sets and these concepts into their daily working practices. So first off then, when we're looking at deploying or delivering some kind of service across a cloud fabric, essentially, we've got to start somewhere. So what is it that we need to achieve? And the whole idea behind this really is thinking about, if we've got this monolithic application, maybe it's built up of a bunch of IaaS services such as VMs, networking components, load balancers, firewalls, those kind of things. How do we actually get those into a cloud service? Now, as was mentioned in the previous session, we've got a number of different options here. We've got things like Azure Portal. We can absolutely go in and point and click and develop and produce this infrastructure and deploy it into our cloud fabric. We've got infrastructure as code techniques that we can use. So things like Bicep, Terraform, Azure CLI or PowerShell, we can deploy straight into our subscriptions and we can kind of build up our solutions like that. So I think, April, the first thing that we need to do is figure out actually what is it that we're trying to achieve. No. And rather than starting with this complex overview of, as this screenshot is showing, we've got a bunch of VMs, we've got Azure firewalls and the like, let's try and break this down really simply.
Absolutely.
So the point of this session, I think, is we're going to talk about Azure DevOps pipelines, and that's going to lead into the things that we can do with GitHub and Github Actions. But for now, what is it that we're needing to achieve? We need to break this down into simple steps. So as a simple thing that we're going to try and achieve, just to start baby steps, if you like, we want to go and do something relatively simple, like deploy maybe a storage account into our Azure platform. So what is it? We need to think about the steps that are involved with doing that process. So as this screen is showing here, basically there are two simple steps that we can follow if we're going to go through the Azure portal. First thing is that we need to log on. We need to authenticate to the service. We need to provide some kind of credentials so that we are authorized to deploy infrastructure or things, resources into the Azure platform. The second step could be quite a simple process of running through a simple form on the Azure portal, filling in our parameters for the resource that we need, in this case, a storage account, and deploying that. So how does that fit in terms of pipelines, and what are pipelines, I guess, is the obvious question that we'll start off by looking at. And we'll park this analogy for a second in terms of a simple process of deploying something. As we've kind of already pointed out, we can use the portal, we can use some form of code, albeit Terraform, Bicep, AZCLI, PowerShell. There are a number of different options. So when it comes to how do we break that down and how do we do that in an automatic way, we've got this concept of a pipeline. Now, in terms of what is a pipeline, this is where I guess a lot of software development concepts and terms kind of get brought into the arena. And maybe we'll talk around a few of these now, April. So I guess the first thing to talk about is, especially if we're going to automate some of this stuff, we're going to have to try and write some code. Yeah, we're going to have to put this in terms of maybe a simple script to deploy our storage account, or maybe even declarative code such as Terraform or Bicep in terms of actually what do we want to deploy. How does this fit into the whole continuous integration, the CI, and the continuous deployment and delivery mechanisms of what goes into making up a pipeline? So maybe we'll just throw back and forth here. So in terms of where we store our code, we've got a couple of different options. From a Microsoft landscape, we've got a couple of options around. We can use Azure DevOps Repos, which essentially is a code repository where we can save our files, we can save our scripts, we can save our infrastructure as code. Templates, ARM templates, whatever it might be, we can store it in that repo.
But why do we want to store things in repo, John? I think that's the important question we want to talk about. So as an IT pro, I have scripts in a folder, right? I mean, Esther talked about it. She used to save everything with timestamps and dates and versions. Let's talk about repos for a second.
Absolutely.
Okay? So why we talk about repositories, we're going to call them source control. Source control repositories, we call them repos for short, etc. But why do we need it? Because it's a form of version control. So instead of going like V1, V2, V500, or using dates when people are changing stuff, it gives us version control of our scripts, and it gives us traceability. So instead of someone going and changing your script and breaking your script, not that it's ever happened to me, a lot, we can version control it. We know what's changing. We can revert them, and we can track those changes, which is really, really critical. So the first reason to look at a repository and source control is to have that, whether that is GitHub or Azure Repos. And we work with a lot of companies that use other third-party tools like GitLab, or they build their own, but then they have to manage that and maintain it. So as an IT pro, there's a lot of concepts we're throwing at you, and I get that. You know, it's scary. There's a lot out there. We have to learn a lot more because developers inherently do this stuff every day, right? We don't. So we need to look at why we want to do these things, and it's okay. We're growing in our career. We're having this growth mindset, and we're enabling ourselves to have more cross-team collaboration. I think one of the big things about source control as well is we can collaborate as a team. We talk about pets versus cattle with our infrastructure as code. Esther talked about that as well. It's really important to have this collaboration amongst our team and to share, and that, we use the phrase, win the lottery, hit by a bus. Going on holiday, I want to be able to leave my scripts and they automatically get executed, or someone else to do it, right? Or maybe I get promoted and someone else needs to run my scripts.
No, absolutely, April. And that's the elephant in the room, I guess, because we're all used to, as IT pros, we go there, we make things happen. We go and write a quick script. We might save it. As you suggest, I'm guilty of that over the years, saving my scripts in all sorts of forms and fashion. Choosing a Git repository is a choice, essentially, to store, as you say, store your code in a centralized repository, centralized area that can be collaborated on, can be worked on by many people. And that is key to it. So essentially, when we choose to store our code in whatever fashion it might be into one of these repositories, we can then start to look at these concepts of CI. What does CI mean? So in that sense that we're collaborating on a piece of code, April, if I were to develop a code that would go and deploy some infrastructure into the Azure platform, as you suggest, I'm away on holiday and you need to update that, you could log on, you could do the modification to that code, and you could save it straight back into that repository. And we'll take a little brief look at that in a second in a bit of a demo. But essentially, we've got these concepts, CI, continuous integration. Now, from the perspective of what does that mean for an IT pro, that is essentially the integration of that code into that central repository. So if you've got multiple people working on that same code base, we can all do those, or many people can do those updates. They can be merged in. So merging being another term that you'll hear a lot about in terms of CI. So we can merge that code into the central repository that then can have something done to it. And this is where we introduce the concept of this pipeline. So when that code is merged in, what can we do with it, April? There's a number of things we could potentially do. So let's just say I've written a piece of PowerShell that does something. I can put that into a CI, continuous integration. What kind of things can I wrap around it in terms of building my testing? Absolutely.
And I'll say this, as an IT pro, when I write PowerShell scripts, years ago, I didn't test my scripts. I deploy them and then we go, hey, let's push the big red button. But now we can test our scripts. We can know what happens before we do it. So we move away from those epic deployments. And that's our continuous integration, being able to integrate our code into the existing code base and test it and merge it.
So we get the green light, essentially.
Green means go.
Green means go. So before that hits production, we've got a mechanism now to be able to make sure that whatever the testing is that's relevant in the context of what we're trying to do gives us that big green thumbs up, essentially. So moving on from that point then, we've got this concept of continuous delivery and continuous deployment. So to try and break these down into a few, well, try and break them down into terms that we might be able to relate to the IT pro world, because I believe, these are terms that are relatively suited to software development, which is probably where some of the confusion or some of the unsureness maybe around what does this mean to an IT pro. So let's just assume that from from a software developer perspective, that we've written some code, we build that particular software application, and in that process of building the application, we're essentially compiling all our code into essentially a set of artifacts that go to form that application. That application could then be run somewhere. So in terms of when we update code, we can have that mechanism to continuously deliver that set of artifacts that can then be passed along and deployed into a test dev area or into a production area. So we've got that continuous delivery bucket. And from there, essentially, continuous delivery moves into the utopia where we can then pass that compiled code, whatever it might be, into our production systems or our dev test systems. So in terms of how does that continuous delivery work in an IT pro world, because we're not writing software here, we're kind of deploying infrastructure, we might be running scripts. How do you see that, April? Is that like a step we can ignore? Do we need to use continuous delivery?
Continuous delivery is kind of this like utopia where we want to get to. And we're going to walk everyone through that in a few minutes of what it looks like end-to-end delivery. The reason why is we want to compile our code, our infrastructure's code, our automation, our scripts, so we don't have to point and click and do all the things. And now people always say when they move to the cloud, they're like, well, I'm going to be out of a job because we've automated everything. No, automation equals value in what you're delivering, but also job security because you've shown that value to your organizations as well. And that's important. So we want to kind of tamper down those fears a little bit because it's tough when you start automating these things. You're like, but I'm justifying my existence by doing these tasks every day. We can be more proactive now. So when we have that continuous integration, we have that delivery. Not only can we deliver it to production, it's already been tested in continuous integration. We don't necessarily have to deploy it to production also. We can deploy it to other environments. And you talked about like a dev test environment or a pre-prod environment. And we can do these things in Azure in really easy ways, whether we're deploying to like an Azure web app or a container. And now in this case, we're just deploying a storage account today. Now we need to be able to scale that, make it reproducible. And remember, I spoke about human error being the biggest issue in how we deploy stuff. So having CI/CD, as we call it, continuous integration, continuous deployment, is all about having that end-to-end model and knowing what we're going to deploy and having it repeatable and scalable. Because it's great to do a resource group. We need to put things in it. And we probably need more than one resource group. Absolutely. And we probably need more than one storage account. Storage is the basis of everything in Azure. So yeah, absolutely. I think end-to-end is where we want to get to. Very much easily achievable. So we're going to talk about some of those things and pipelines in a second. And then we're going to go into the demo and show you the kind of beginning to end delivery model.
Yeah, absolutely. So let's move on then. So in terms of what we're going to look at now, let's just have a quick recap over what pipelines actually gives us then. So we can use any language that we like. It doesn't matter what we use. We can write in any code that we like. We can bring in any scripts that we like. Source repositories, we've already touched upon those. Azure DevOps Repos, GitHub, the place that we're going to store our code, that central repository that we can all collaborate and work on. We can tackle things from the relatively simple, like deploying a storage account, right the way through to relatively complex environments with multiple stages, multiple pipelines even. So we're really not limited to just one thing here. In terms of build locations, so this is probably a concept that we need to explain a little bit more of, but in terms of build locations, we've got here two options, essentially. We can either have an in the cloud hosted environment to run our code and run our deployments, which in this case will show you the ADO, the ADO hosted in the cloud runners, another term there to introduce. And we've got the option to have physical compute in our own private data centers. And maybe we'll talk a little bit around why we might want to do those things.
I think the difference is if any of you have ever run any testing tools locally on your machine, sometimes machines don't allow it. Lack of compute on a machine, there's ways to work around that we won't get into today. But when we run and build and test our code using these third-party tools like GitHub or Azure DevOps, we're using these runners to do all these things for us. So we spin up a runner as we need it, and it spins down. So when these are cloud-hosted, both Azure DevOps and GitHub use the Mac OS, Linux OS, and Windows OS. So we can literally test against any software application that we need, or even, you know, for infrastructure as code. So those are cloud hosted. When you do the private hosted, you can do those on-prem. You can actually do privately hosted in the cloud as well. They run on VMs, VM scale sets. The downside to having those locally hosted is that there's networking consideration, there's feeding and watering. We have a lot of customers that do it for data residency, so you have to kind of pick what works best for you as an organization. There's licensing mechanisms around it, but basically this is building and running our code. This is the compute mechanism behind it, so that we can then deploy it. And then when we build that thing, we package it into an artifact, right? And then that is ready to release. That's our CI done when it's in an artifact. And then we put that into our continuous deployment pipeline.
Absolutely, yeah. I mean, just to pick you up again on those build locations, I guess there's always that security concern as well. You know, rather than using cloud services, if you've got an on-premise environment, I've said that word, sorry, I thought I scrapped that from my vocabulary now. But if we've got that private data center type resources that, look, have no communication with the outside world, maybe they're air-gapped systems, we can host these on local resources to talk to those resources and deploy onto.
But I think most of our customers are multi-cloud or hybrid.
Absolutely.
I would say most. There is some stat in Microsoft about how many customers are hybrid, but most of our customers are coming from an on-prem environment, and a lot of them use multiple clouds, whether that's, you know, AWS or GCP, et cetera. So the cloud-hosted runners allow you to go to those different clouds, and if you need to have a private compute option for the locally hosted, that's available as well. So those are really important. And then we're going to talk a little bit about builds and pull requests in a minute. So before we jump into that, we're going to explain what a pull request is and why that's important. And what else do we need to know about before we start doing these pipelines?
Yeah, I guess, you know, it's really important. I know we're not focused on as such in this session, but Git and the ability to understand and learn a little bit about Git. This is where pull request comes in and merging your code. So, I mean, at a high level, you know, what is a pull request? It's when somebody is doing a modification to a piece of code or a script that you may have written. However, you don't want them to save it directly over your file. So it's like opening up a notepad file, doing some change and save it. You know, how many times have we done that in the past? And it's not worked and you've gone, oh, how am I going to get that back? So the idea with a pull request is that with Git, we don't just overwrite the existing file, we create a new branch. So this concept of branch, another concept that we're introducing in terms of Git, we create a new branch, which is essentially a fork from our original repository. They can all be controlled, so I can do my modifications in that branch and I can test against that branch. And I can do whatever it is that I need to do. But when I'm ready, I can then merge that in with the main branch when I'm happy that all those tests have passed. When you know, people have reviewed my code and said, yeah, that looks good, we can do this thing called a pull request, which is essentially asking the owner or the approvers of that Git repository, can I merge my code in with the main?
Well, let's show them how we do it. Let's dig a little bit deeper into these. Let's pull it up into the demo.
Yeah, well, I was going to say, firstly, before we do that quickly, you know, how do we build these pipelines, April, in terms of what is the underlying thing that we have to kind of be aware of?
Yet another markup language.
There we go. So let's say hello to YAML.
Yes, YAML. YAML has entered the conversation.
Absolutely. So this is where we'll break out now. I guess we'll talk a little bit about YAML now as we go through. So let's head on over to the demo and take a little look around Azure DevOps.
All right, John, so we're in the tool Azure DevOps. So for all of you following along, DevOps is the practice, and Microsoft has this tool called Azure DevOps. Azure DevOps is cloud hosted. You can also run it on Azure DevOps server locally in your data center. It is a tool that allows us to literally deploy any language to any cloud. And I literally mean any language to any cloud. So a lot of our customers that use Azure DevOps, the product, are deploying to their on-prem data centers. They are deploying to AWS, GCP, and Azure, and we can do that through the pipelines. So what we deploy into Azure, we can also deploy into other places. Now we need different types of infrastructure as code and different methods, et cetera, especially for the different clouds. So we're not going to get into that, but let's review what Azure DevOps is made up of. This is a fully mature product, and Azure DevOps has been around since officially 2005. It was actually released in 2006 under Team Foundation Server. But this is the mature product. It's cloud hosted. So the first element of Azure DevOps is Azure Boards. Now, when we talk about DevOps processes being a cycle, we want to go into the planning phase. Anytime we begin work, we begin here in Boards. We plan our work out. We can see what our team has on the backlog, right? So many teams, especially in the IT pro world, We'll run, we talk about running stand-ups. Esther talked about why these stand-ups are really important. You can run your retro from Azure boards. It's a great tool for planning. So your PMs love it for visibility. As an IT pro, you can see what work your team needs to work on. And if there's any fires to be put out, we put them in as tasks and we can allocate them to the team. And it allows us to have a backlog of things that our team needs to be working on. It's a fantastic tool. We're going to put more info in a link below for you about Azure boards, how you can read more about it. And it is such a feature-heavy tool. Absolutely love it for planning. Next up, we have Azure Repos, which we've spoken about. This is our Git repository. Now, Azure Repos holds your code. This uses Azure Active Directory on the back end, and your code actually sits in your Azure tenant in terms of data residency. So for us here in the UK, we can have that UK data residency option. For those of you outside the UK, you can have that data kind of under that Azure tenant and allocated to that region that you're in, which is really important when we talk about security and compliance, because every time we talk about the cloud, security and compliance is number one. But this is our code. This is holding our YAML file, which is our pipeline file that we're going to talk a little bit more in depth in a minute. We have some other scripts in here, etc. And this holds everything. And there's other things in repos here that we can see. We can see the files. We can see commits underneath that. Commits shows us when we've made a change. So again, we talked about not overriding each other's files. We talked about this thing called branching and pull requests. We're going to go into those in a minute. Next up we have pipelines. This is our delivery mechanism. This helps us with our CI/CD. This packages our code and delivers it out to our environments. And do you want to look at a YAML file?
Why not? Shall we?
Let's look at a YAML file. Barbara's going to go really in depth into this, but let's just look at it really briefly. So this YAML pipeline here, we can see at line 6, there's a trigger. All these pipelines are going to be triggered by some activity, right? This trigger here is off our main branch, so that when we create a branch in a minute, it doesn't trigger this pipeline to run. And I'll explain why that's important when we make changes to our code. You can see on line 9, it calls the pool, the VM image. It's running an Ubuntu machine as our cloud-hosted runner. Because we're doing a cloud-hosted runner, it's irrelevant whether it's Linux or Windows for what we're doing. But in many cases, if you're testing software applications, that cloud-hosted runner is really important. Next up, we have a job. And this one's just going to shout out, hello world. Really, really simple in our pipeline run, because we just wanted to do something simple and fun for you all. And then next up, we're deploying some resources. This deploy resources task connects to our Azure subscription. And if you notice in line 26, John has put in a variable, very smartly, in his pipeline. So remember I talked about in my intro how we don't want to put plain text passwords in our repositories or anywhere. John has created a variable for a subscription. Well, that's not necessarily a password-enabled thing. It's best practice to take those things and put them as a variable. So John did a good job on that one.
High five.
All right. And this is running a bash script. So anytime you need to run like PowerShell or bash scripts, you put this into your pipeline. This pipeline's great, but this doesn't deploy our storage account.
Yeah, well, that's what we want to look at, I guess.
Let's do it.
Let's have a look at that. Yeah.
But before we go, when you talk about test plans and artifacts.
Yeah, okay. Yeah, should we jump on over? We'll have a little look at those first.
Yeah, we'll have a quick look at that. So test plans. Testing is absolutely critical with what you do in your organization. We should be testing all of our code before we deploy it. For PowerShell, there's pester testing. For Terraform, there's TerraTest. There's so many different types of tests for so many different types of things if you're using Bicep or just other things. So you can create test plans in here, track it. You can see your test runs and successes and failures and trace things over time. And you can produce reports for compliance as well. Again, compliance is another critical word. And then this artifact thing. You can create packages of your software or your code in the artifacts. So we don't have any right now, but you can connect to external sources as well. So those are kind of the 5 elements that make up Azure DevOps. But let's go ahead and make some changes. So our code is sitting in our Azure Repos, right? Is. So it is here. And if you notice on the top right here, it says to clone our code. This means we clone it locally to our desktop. We don't want to make these changes in the browser. I mean, we can, but it's actually quite messy. So we want to enter in an IDE, an editor for our code. So John has already pre-cloned his code. It takes a couple seconds. And he's going to open it up in Visual Studio Code. The reason why we're using Visual Studio Code is it's a great editor. So for those of you that write in PowerShell may remember the ISE. I was actually really sad when the ISE went away.
Yeah.
But Visual Studio Code is way more betterer.
Betterer, is that
Better.
a word? Yeah, absolutely.
No,
it's a good
it's
word.
not,
It's a
but
good
I
word.
think it's more fun to say. But no, Visual Studio Code's great. It has extensions for pretty much everything you want to write and do. So they have things, if you're writing documentation for your project, which we all hate documentation, but is required, you can do spell check, grammar checks, etc. When we're writing code, we put in extensions for like PowerShell, linters, testing tools are all extensions. They help us write better code. Visual Studio Code has so many great features we're not going to get into today. We're going to put a link in for you so you can explore more of those options and all the great features. The other cool thing about Visual Studio Code is it has what's called live share. And if you've ever tried to get help on a project and you've shared through Teams, you know exactly how painful that is. It doesn't work. There's a massive delay. So you can configure live share to share your code and your screen with other people. So if John and I happen to be in different locations, which we normally are, right? We can do live share and collaborate on this code. So that collaboration piece is really important in DevOps. So what are we going to do? We need to actually create a file to deploy a storage account.
Absolutely. Well, I mean, using that concept, it's great that we've just gone through the steps in that YAML file there to create our pipeline. But let's just imagine for a second that we've got that whole bunch of scripts that we've got to do stuff with.
Yep.
And essentially, we're back to our example now of the simple task of deploying a storage account. So what do we actually need? So as this, we're on the Azure resources.sh file here. It's a little bit of a bash script. Actually, it's running a couple of AZ CLI commands.
Okay.
So back to those self-hosted runners, those runners come with pre-installed packages that we can use to deploy our code. So with that, AZ CLI is all working up and running. We can use that straight out the bat with a self-hosted runner. You can see there by our code, we're not doing anything too complicated. Back to that simple steps, we're going to create a resource group, and then all we're going to do is deploy a storage account into that resource group. So it's essentially 2 lines of code that we've got there. Also got the equivalent in PowerShell. Maybe PowerShell is the language of choice or the scripting language of choice that we want to use. It doesn't matter. We just need to understand that there are multiple ways of doing this.
Yep.
From an IT pro, and your choice might be different to the next person's choice, or you might be in a different context.
You have to pick the tool that's right for you, and there's no one answer to everyone. We always say it depends, right?
Absolutely, and this is the beauty of using VS Code to store our repository, because back to the point, we can use those plugins to help us write that code, and kind of analyze that code. But then using Azure DevOps, or maybe even as Barbara's going to go into a little bit later on, GitHub Actions.
Yeah. Okay, John, we're going to make some changes to our code. Now, on the bottom left-hand side here, we can see that in the green, it shows us we're connected to Azure Repos, right? So it tells us we have a connection that uses Azure Active Directory. So it's using our Active Directory account to authenticate. That is our security backbone. And then to the right of that, it says main, and that shows our branch. So remember, our main is that main branch. That is our primary area of working from code. So instead of doing V1, V2, V3, we want to create what's called a branch. Now, John, go ahead and switch our branch up.
Yeah.
So we never want to make changes to our main branch. We want to get a branch off of it. John's created one, and he's called it John. Very
imaginative. Yeah.
I like it, but that identifies it as his, right? And each company has different naming organizations, etc. We're going to put a link for you to reference branching policies, etc. here that you can explore more about it, but. In this branch, now we're going to make our changes to our code. So John's going to go ahead and make that change from his branch. Have you made your changes?
Not yet. So let's call, we're creating a resource group. This code is doing something really simple, creating a resource group, create a storage account. So let's just go and switch up those names. So let's just call this John resource group, and let's call our storage account John's storage account. And let's pick some random numbers because we know how storage accounts love those number systems. So there we go. I've made some changes to my code. What do I do next, April? Save it away, yeah.
Save it away. And if you go to the left-hand side on your screen, we can see the little branchy tool. We click on that, and it says, it shows us we've changed a file. Awesome. So we can actually select, we have to stage it, which is a bit of a step, but we hit the little tick box. We want to commit that. It means we want to push that up to our repository. So John's going to update his code. Also, it's really important to put a little message of what you're doing and why, so that if it does break, you can revert it, and it gives you that traceability. So John's going to go ahead and push that up. It's going to commit those changes. Great. So we can see that it's pushed up. John's going to go into his Azure DevOps portal and look at his branch. So his branch is in there, and actually it shows us at the top that we've updated the branch called John. Then it asks us to create a pull request. So what is this? We've made code changes on a branch so that we're not affecting our main single source of truth of code for our infrastructure as code. And then after we've pushed that up, we create a pull request. A pull request is a request for a review. Think of it that way. So John's going to create a pull request. Now that we've created that pull request, we give it a title. Again, we're just going to keep the default title for now. Usually we want to put it in description, and we can update this. We can add reviewers. So you don't want to usually review your own pull request. Best practice is usually 2 reviewers, maybe one from 2 different teams or different people in the team with different roles. John can add a reviewer. You can also link your work items. Remember those tasks. So if John was given a task to create the storage account, he would put it in there. We can also tag it, and then he's going to go ahead and create that pull request. Now, when that pull request is created, those reviewers are going to say, oh, I need to review this for John. Automatically, Azure DevOps says, oh, there's no conflicts in your merge. That means that it's checked our repository. There's no conflicts as in we haven't updated things the wrong way, etc. And then John can literally hit approve, and that will kick off that YAML pipeline. Because remember, our trigger was a push to the main branch. So hit approve, and we can go ahead and complete it to the right. You can also set that to autocomplete. And we call this a merge. So John's code is going to now go from his branch, and you see the little pretty picture, into that main working branch. Complete your merge, John. And let's go over to our pipeline. Now, it does check for merge conflicts, and you can show it merging the pull request. So you can actually see it from here, and you can click on it. And then if we go to our pipeline, we can actually see the pipeline running. So we can see the pipeline running here. It is getting ready to find that cloud-hosted runner. It's going to build our code and deploy it. So we can see it's running his first task that we saw in that YAML file. It's running that pre-work. Wow, it's already done that. Okay, that was fast. All right, John, so our pipeline has ran successfully. We made some code changes. We created a branch. We did a pull request. And of course, we followed good procedure, right?
Mm-hmm, yep. Of course.
But just for the demo point, we kind of skipped over those other intricacies at the moment. But we ran that pre-work, right? We looked at the jobs here. On the left-hand side here, in the jobs that was ran, we can see that it ran that pre-work thing, and we can see that it ran that one-line check and output hello world on line 14. That just gave us a little script to run, which is easy to do. And in a normal pipeline, you might be running a bash script or PowerShell script, some configuration things, because we know we need to do little tweaks for our environment and our infrastructure, right?
Absolutely, and I suppose it's those things that we need to think about as IT pros. So typical things from an infrastructure perspective are: do we need to update some firewall rules?
Mm-hmm.
Can we put that into a pipeline? Do
Absolutely.
we need to do some configuration to other resources? Mm-hmm. We can think about what we can put into these repositories.
Absolutely. So that's just an example, right? And if we go down a little bit, we see the next job that we listed out in our YAML pipeline was deploy resources, and it matches up. So this went in, this initialized the job, this logged in via Azure, went into the Azure CLI, and deployed that script for us, that bash script. So John, let's go over the Azure portal and see what deployed.
Mm-hmm. So there we go. We've got our resource group, John-RG for resource group. And in there, we've got our storage account created. So awesome. April, we've done a really simple thing here. We've deployed one resource into an Azure resource group. But think of this on the wider scale. So, I mean, should we jump back over to the slides and finish off the session, do you think?
Let's do it.
Okay, so I mean, I guess let's just recap and flick through these slides. So we discussed what a trigger is, yeah. Yep. So that concept of our code changes, checking those in using pull requests, something to trigger our pipeline and actually do the thing that we want to do.
Yep.
Moving through the stack of the pipeline, so stages and approvals, you mentioned those, April.
Mm.
We might not just want to do some code changes and have that straight into our main branch. We want somebody to approve it and
and we can put in manual checks as well. So we've automated everything end to end, but we can create stages for maybe different environments, different types of code, different things we need to do. And we put in different jobs, and we can have manual approvals between the stages. Sometimes we just need manual checks. We run all our automation tests, but maybe we need someone higher level to check it, make sure it works, and just get a second set of eyes on it, right?
Yeah, absolutely.
So we can have, and then we can also, some of our approvals can also have things against like Azure Monitor or Splunk monitoring to get that tick box that we've hit, all the things we need to hit in terms of performance before it deploys to production as well. So there's ways we can gate these approvals.
Yeah, back to the point, what is it that we're trying to achieve? Yep. Yeah, so moving on from that point then in a pipeline, agents and jobs, we talked about what an agent is, those self-hosted runners in Azure DevOps, or we can use on-prem, or those privately hosted piece of compute to run our code. So moving on from there then, in terms of when we look into the job is comprised of a number of steps, and those steps comprise numbers of tasks. And this is all denoted in that YAML file. And we can declaratively say what those steps should look like. In our example, we had a very simple script output, hello world, but we also included the deployment of some Azure CLI through a very simple bash script. That could be any number of complex operations that you're looking to achieve.
If you think of it as an IT pro, I worked for an organization that was a very, very manual organization. We had printed sets of paper for every server deployment, and we had tick boxes we had to do.
Sure.
So if you think of your YAML pipeline and these steps as those tick boxes of all those tasks, those things then get translated into your pipeline. So if you think your pipeline is you're building all this stuff, you're doing all the tick boxes, you're testing it, and then you're deploying it. That replaces those paper exercises without question.
Absolutely. So I guess, April, we're bringing it all together now. So, kind of to bring this session to an end, we've been through the whole process. We've seen what the run of an ADO pipeline looks like to deploy potentially this complex environment. So, what that looks like in terms of the components that we've used for ADO is essentially what we just talked about. So should we recap on what we just run through?
Yeah, so when I introduced DevOps, I talked about it being delivering value and a full cycle, and DevOps never ends. So we want to pick the things that hurt most in our organizations and start there. So if we look at this diagram here, we have Azure DevOps, and this is the little board symbol. So this is our planning. As an engineer, as an IT pro, we need to plan what we're going to do. Then we need to use that IDE, that editor to make changes to our code, whether it's infrastructure as code, even wiki documents. That then gets pushed to our repository. So in this case, we used Azure Repos. Then we deployed it to Azure DevOps pipelines. And then from there, we deployed things. We deployed we didn't deploy virtual machines today, but we deployed some storage, and we could build some virtual machines on top of it. We could deploy literally anything in Azure with those pipelines. Then we hook in monitoring. Monitoring is that production level environment that's really, really key. Whether you hook in Azure Application Insights, Azure Monitor, etc., that's really key to really completing that monitoring in production phase. Then we come back around and we look at the output of what we've deployed. How has it impacted us? What value did we deliver? So when we talk about delivering that value, what was our time to deploy? What was our time to remediate? And maybe what the performance differences are in our infrastructure because of the changes we've made. Then that goes into our planning phase, back into Azure DevOps for the next cycle, so that our engineers can then make improvements for the next, what we might call a sprint or the next deployment cycle.
Absolutely, April. I think the only thing that I would add to that, for those IT pros that are looking to get started, maybe they are a little bit, lacking the skills at the minute with, what does an ARM template look like? Use the Azure portal to your advantage. Yeah, we know that we can deploy things through ClickOps in terms of clicking through the menu system and deploying it. But every time we deploy something in Azure, it gives us that ARM template. We can pull that ARM template up, and let's try and use those ARM templates maybe as a first mechanism.
And even better, there are repositories hosted on GitHub that have Azure Bicep files, PowerShell files, everything, and Microsoft Docs. And we'll put links below to get you started on Azure PowerShell. With deployment, we'll get you started on Bicep, even Terraform. We'll put all these links below as references that you can then reference to getting started to create these templates, because you don't need to start from scratch, right? So thank you, John, so much today for telling us all about the CI/CD mechanism and showing us everything. Really, really awesome.
My pleasure, April. Thank you for having me on.
Always good to have you. Always welcome. So thank you everyone for joining for this session. We have Barbara Forbes coming up next. She's going to focus on infrastructure as code, and then she's going to go deploy these things out of her pipelines, and she's going to show you how to build the pipelines. So stay tuned for the next session, and then after that, we have the Q&A. So see you all very shortly.
All right. Thank you, April. What we're going to do now is to see how we can put some stuff into practice. We've learned a lot about all the things that you can do with Azure DevOps. So it's now time to create our own pipeline. We'll first look at Azure DevOps, and then we'll take a look at GitHub Actions. So Azure DevOps, one of the great news about that is that you can get started for free. So if you want to play around, if you want to have a lab and see how it all works, you can do that. You just go to dev.azure.com and you can create your account with your Microsoft personal account or with a GitHub account. So nothing is stopping you there. If you start using it in a company, you can get started for free as well. Of course, you need to start paying at some point, but you can come pretty far just playing around with it. So let's move back to our project that we had, the Tech Days project. We need to start with our code, of course. So we'll start with the code here in the repo. For this use case, we're not going to use the PowerShell or Azure CLI, but we're going to use Bicep. This is a new language. It has been around for about a year, and it's a wrapper around ARM templates, which you can use to deploy stuff. We will stick with our storage account. The reason for that is that a storage account can deploy pretty quickly, so you can practice it a lot of times in less time. So here I've created storageaccount.bicep. And we'll wait for it to open up. There we go.
If we look at our file here, we can see here a bicep file that creates a storage account. It uses a parameter for the storage account name at line 1. The parameter is so that it's flexible, because maybe we want to deploy multiple storage accounts and we don't want to create templates for each of them. The next parameter is the location, and it is set to a default value, so you don't have to fill it in each time. And then at line 4, we see the resource itself. This is all you need for a basic storage account. You can add more properties, but this is enough to get started. So we now have our file, which we can deploy. Now what Azure DevOps needs is a connection to Azure, so it can deploy it for you. And to do that, you use a service principal. But Azure DevOps can help you create that one. Let's see how that goes. We'll go to the project settings, right here at the bottom. And in the project settings, we're going to use the service connections. We'll look over here, scroll down, and here is the service connection. I have one already because I have tested this pipeline. But if you're new here, you just get one big button with create your first service connection. If you have one already, we'll use new service connection. And here we can choose a bunch of connections. There's a lot of options here, but we were going to focus on Azure. If you're not that familiar with it, you might think Azure Classic is the way, but that's kind of a legacy protocol. We don't actually use it anymore. What you use is Azure Resource Manager. That's the current management tool. So we'll click that, scroll all the way down, and click Next. And now we see a few options that we have. We can have an automatic service principal, a manual service principal, managed identity, or publish profile. For this demo, we're going to go with the easiest way, which is an automatic deployment. So we'll click Next. And here you can see it zoom in to my subscription. So it's loading my Azure account. It takes a while to load, and it's probably going to ask for credentials. So there we go. We'll sign in. And now I'm signed into Azure right from Azure DevOps. So I can select the subscription that I want to use, and I can select a resource group if I want to. If I do that, then this service principal will only have permissions to do something in that resource group. I wanted to have permissions on the complete subscription, which it will automatically get. It will get contributor permissions. So we'll give it a name so we can refer to it in our pipeline. And I'll call this Azure Demo 02 because, as you see, 01 is already there. So we're going to use that in a second. And I can save this, and it's now creating a service principal in my Azure ID. The good thing about doing this from Azure is that, from Azure DevOps, is if you delete it in Azure DevOps, the connection, then the service principal is deleted as well. If you do a manual connection, then you need to do that yourself. So we have a connection now. Now we are ready to create a pipeline. To do that, we go to the rocket right here. We choose a new pipeline. And again, if you don't have one, there will be a big button in the middle. It selects to create a new pipeline. And the first thing we can select is where our code is stored. And as you see, it doesn't have to be in that Azure repo that we just selected. It can be in other providers or in GitHub. So you can combine them with each other if you want to. But we've just stored our code in the Azure Repos, so we'll select this one. And here we can click tech days, which is the name of the repository that we're using. And now I can configure a pipeline. Notice here that I can choose for the starter pipeline, but I can also use an existing Azure Pipelines YAML file. And that's the great thing about using YAML. Like April and John already told you, if you use a YAML, we can create it once and then use it again and again. So it becomes part of your infrastructure as code. So that can be very helpful for all those times that you want to create multiple storage accounts or other kinds of infrastructure as code. But as we don't have one now, we're going to use a starter pipeline. And the basic YAML is created for us. And we already saw that in the previous talk. But now let's start creating the steps. An important thing to realize is that the pool by default sets to Ubuntu, so a Linux image. You can also use Windows Server or Mac OS if you want to create applications. If you need to choose between Windows Server or Linux, I recommend using Ubuntu because it's a little bit quicker. But not all tasks can work on all OSs, so you do need to test if it actually works on Linux or if it's maybe something that only works on Windows Server. And here we have the example steps, which we're going to remove because we don't need them. And we want to keep our pipeline clean. And now we need to start creating YAML. And this can be a bit daunting if you come from a Windows background, because we don't work with YAML that much. The good thing is that the website will help you create the YAML, which will make it a lot easier to work with. One thing that is important to realize is that indentation matters, and you might not be used to that, so something to be careful with. But what we want to do is deploy that template we just created, and we can use the assistant that you see right here. So I choose Show the Assistant, and now I have a bunch of tasks here that I can use. There's a lot of tasks available, and you can even add more tasks from the marketplace. But let's focus on our ARM template. I can use the ARM template deployment task even if I'm deploying bicep files. And as you see, I get drop-down menus to add everything. So I don't have to worry about code, and I don't need to know what the syntax is. I can just do it from here. I can select a connection, which we just created, the Azure Demo 02. And I can select the subscription, which it will collect from that connection. And now I can choose to create or update a resource group. Notice that it doesn't matter if the resource group is already there. The step will check if the resource group is there, and if it's not, it will create it. And tech days is in a resource group I already created, so it's again in the drop-down menu. And the same thing goes for location. You always need to set what region your resources should be in, and I get a drop-down menu. So I don't have to remember what the syntax was or what it was called. Now we are in Western Europe over here, so I'm going to choose Western Europe. And now I can set the values for the template itself. So here I need to set the path to the template. One thing that's important to recognize if you have a Windows background is in Windows we use backslashes between folders, but in Ubuntu we need forward slashes. Can take a bit of getting used to. So we'll add a forward slash and then storage account.bicep. If we have multiple folders, we can create a structure in here. So now we refer to our template. And here we can set the parameters if we have a file for that. So if you're using a parameter file, you can set the path here. But we just have one parameter, so we don't have that file. But we can add that parameter here because we need to set the storage account name. So we'll say storage account name. And then we need to come up with a name. And what I will do, I will start with tech days and then add a random string because the storage account needs to be globally unique. So let's hope we got that right here. And then I can set the deployment mode. You can choose between incremental deployment or complete deployment. If you do incremental, it will look at the resource group that is there, and if there's something in your template that is not in the resource group, it will deploy it, and it will change stuff to existing resources. But if you do complete mode, it will check your template, and if there's resources in the resource group that are not in the template, it will delete them. So that's good to be aware of. It means that something can get deleted if you're not careful, and there's no way of recovering that most of the time. So if you're getting started, I recommend starting with incremental and have a lot of testing before you actually go to complete mode. But here's another option we can use, which is validation. So this will just check our template to see if it's a valid template, if it's something that can be deployed. So there we more or less have our first test out there. So let's use that one. So we are done with everything. Now, one thing that's important is that your cursor is in the right place. So this is where we want our task to be. And I'll click Add. And our task is added right there. So all that YAML, I don't have to write that. And of course, with time, I want to use this YAML to create other tasks because I don't want to use the assistant all the time. But this can really help you with setting the right syntax to get started with it, because it does show what it will do. But this, with the assistant, it's easier to get started with it. So I'm going to add one thing, and that's a name to this task. And I'll call it validate, because it's not deploying anything. Of course, I don't only want to validate, I also want to deploy stuff. And we have created this already, so now I can just copy and paste it. So I'll copy this, and I'll paste it. And now here I can change this one to deploy. And there's one thing we need to change, and that's the deployment mode. And we can do that right here, because it shows here that's the deployment mode. But I want to show you that there's actually a settings button right here. And if you click settings, it opens that assistant again, and all the settings are in there. And I can just change it in the drop-down menu. So I'll change it here to incremental mode. I'll click add. And now this setting has changed to actual deploy incremental instead of just validating. So there we go. We can now save this. Click save and run. And what this does is create a new file in your repository. So it's now part of your repository. It's part of your code. So everyone who gets your code can see what is going on, which really helps if you're working with teams. And the job has now started. And we can follow along with the job. We can see what is happening here, which is really great. As you see, it uses an agent in the cloud, so I don't have to worry about provisioning a VM. I can do that if I want to, but if you're getting started, I recommend doing it like this. I also recommend if you're working with pipelines for the first time, or if you're doing some complicated stuff, it's probably going to go wrong a lot of times. I know that because we've all been there. So that's okay. This is a great way of learning how these pipelines work. And you will feel very happy if you've tried it a bunch of times and it's finally working. So don't just get discouraged if it doesn't work straight away. It might take some tries to get it working. And at this point, the validation is already done, where I can see the logs and I see the validation was completed successfully. And it is now deploying my storage account to my Azure resource group. I can follow this in Azure if I want to as well. But as we said, storage accounts are very quick. So it's already done with the deployment. So the whole deployment is done. And if I look now in my Azure portal, I can see a storage account that's created. So we now have created our first pipeline in Azure, just like that, or in Azure DevOps, just like that. The next question is, what about GitHub Actions? Because that's relatively new compared to Azure DevOps, but they both exist and you can use them both. And I want to show Azure GitHub Actions because if you get started with one of them, the other one is pretty similar. GitHub Actions has a little less of the menus and the steps to help you. So you need to do a little bit more stuff yourself. The good thing is it's all very well documented. And if you get the structure that you use with Azure DevOps, you can do it with GitHub Actions as well. The other good news with GitHub is, again, you can do this completely for free. If you use a private repository, in that case, in a private repository, you get a certain amount of minutes that you can use. That's the same thing with Azure DevOps, but it takes a lot of effort to reach the end of that minute. And I've played around with both of them for a long time, and a lot of times I've never been close to reaching that limit. So don't worry too much about it. If you are worried about it, you can always create a public repository to work with, and then there's no limitation. So here I have my GitHub repository. And in this GitHub repository, this is basically the same repository as we had in Azure DevOps. So I have a storage account.bicep file that I can use. So I can use this one, but to set the connection to Azure, I need to take a little bit more effort because I need to create a secret with a JSON file that has some information about the service principal. So it will not create it for us. The good thing is, if we look at the documentation at Microsoft Docs, here we see a complete guide on how you can create that workflow. How you can create the service principal and then the JSON file and add it to GitHub. I've already done that part, and if I look at the settings here, and I look at secrets, we see the credentials are already there. And notice that I can update credentials and I can remove them, but I cannot view them. So that's pretty nice if you're sharing this repository. But do notice if you're sharing a repository, everyone has access to these credentials and can use them in a pipeline. So do be careful who you give access to your Azure deployment. And now what we need to do is use actions right here. And in Action, you can create a new workflow. I'm not going to create it all the way down. We're going to look at the workflow that we already have. And what we'll do is say, view the workflow file. As you can see, again, this is YAML, and it's very similar in structure. It has a lot of comments by default that tell you what each step is doing, which can really help. And let's see what happens if we try to edit this file. Here we have the marketplace on the right, which can help us with our tasks. So if we look at the task here, we have the Ubuntu latest version again, which we already saw in Azure DevOps. One different thing is here that we need to log into Azure separately. So there's a task for that. And as you can see here, it's using that secret that we just show. After that, I have deploy a bicep templates, which is pretty much the same task as we had before. It uses that storage account.bicep and it sets the parameter manually. So it's very similar. So that's a great thing to consider to look at them both. So we're not going to add all those tasks anymore because they're already there. But I do want to show you a few little tricks that I use when I work with GitHub Actions. So let's say we want to do that Azure login part. On the right side, I can search the marketplace for Azure login. And here it is. That's the task that I want. So I'll click on this action and I take the latest version, and here all the code is already available for me. You see, it's not a drop-down like we just had, but I can copy this, and there are a lot of comments in here that show me how I can use it and what each parameter does. So I copy this, and I'll add it right here. And now we have that issue that we had again with the indentation. It's now at the beginning of the line, and it needs to be at the same level as the previous action. So I need to add a lot of spaces to get it at the right position. What we do first is make sure we can select the whole thing at once. Saves us a lot of time. So what I'll do is press my cursor here. I'll press Alt, and it becomes a little plus. And now I can drag my mouse all the way down. And now if I press space, the whole action has one extra space. So I don't have to do it for every line because that's going to take a lot of time. But now I need to consider that I actually have to check what the right indentation is. And I never feel like that. So my trick that I do, I just press space slowly until that red squiggly line is gone. So there's a wet squiggly line here that says this is at the wrong indentation. And I'll press space. And now it's gone. So that means it's now at the right indentation. There's no problem anymore. Now all the other parameters start complaining because they need a value, which is good. But now I didn't have to check where the indentation actually is. So that's just one little trick, makes it a little bit easier to work with actions and the YAML file. Now, if we would commit this file, this is the result that we would get. So again, very similar. It does an Azure login. It deploys the pipeline. I can check everything and it creates a storage account in our Azure subscription. So now we have seen how we can do that in Azure DevOps and GitHub Actions. So we can use those tools, as you see, to get started with it. It's not that difficult as it seems when you're not familiar with the concept. So I do recommend just try it out. You've heard a lot of concepts and just see if you can create your own pipeline and see what you can add. Maybe you can add testing to there. Maybe you want some manual proofing in there. Maybe you want multiple stages, as we saw in the talk by John and April. You can do all of that. Just start out small and start building into your pipeline. You're going to have so much fun, and your code is going to be more consistent and more secure. So only good things happening here. And with that, I want to thank you for all your attention, and I'm going to give it back to April.
Thank you, Barbara, for really showing us how to put that all together and deploy and configure that pipeline. So everyone who's joined us for all of these amazing sessions, we start off with Esther, who really hit us with those core concepts to introduce us to, how do we deploy things and why we need to use source control and why all these DevOps principles are important to you as an IT pro. Then John and I kicked off some of the components of these DevOps tooling and help you kind of show the end-to-end stuff that kind of needs to be filled in. And then Barbara tied it all together with infrastructure as code and showing us how to build that pipeline in both GitHub and in Azure DevOps. So now we're going to go into the Q&A, and we want you to ask all of your questions to us. And we're going to be here live to show you stuff that you may have questions about from the demos or any other questions you have about DevOps for you as the IT pro. So give us a minute for a costume change, and we'll be right back for the Q&A. Hello, everyone, and thank you for joining us for the live event, Putting the Ops in DevOps. So we've had a little bit of a costume change, but we wanted to make sure we could answer the plethora of questions in the background that were going on during the live event. So now we're going to run a live Q&A where you all can ask anything that you want about the sessions you saw, and I've seen some great conversation in the chat. So let's have those conversations live and bring everyone in from the community. So before we get started, I'm going to go ahead and welcome in our amazing hosts and guests today that are subject matter experts on this subject. So first up, I'm going to bring in Esther Bartel. Esther, welcome. Esther's on mute. We're going to learn how to do this in the year 2022 is how to come off mute. Still don't hear Esther. Uh-oh. We broke the internet. You're here. I hear you.
Yeah, you can hear me now.
I can hear you now. So Esther, tell everyone out there a little bit about yourself.
So I've been in end user computing for over 20 years. Loving all the IT stuff. First of all, working a lot with virtual desktops and then transitioning to automated deployments and automated configurations of both infrastructure and the application layers. And that got me so excited that I'm now finding myself loving this whole new DevOps role, engineering, and all the excitement that comes with it. So happy to share my knowledge and experience with the community.
Awesome. Thank you for joining us today. And next up, we have John Lunn, aka Johnny Chips. Welcome, John.
How you doing, April? Nice to see you again.
I know. So it was great we got to do our session together. Can you go ahead and, for those who don't know you, which I don't think there anyone out there that doesn't know you, but if anyone out there doesn't know John, would you just give a moment, introduce yourself to everyone?
Yeah, of course. Hi, everybody. Yeah, thanks for sticking around and watching the sessions. Been awesome sessions. Well done to Barbara and Esther as well. Really enjoyed that myself, watching through it all. But yeah, my name is John Lunn. I'm based over here in the UK, work for a small telecoms company called BT as a cloud technical architect. So yeah, been in the industry for probably too long now is probably the reality. But yeah, all these concepts and, the ways that we can work today with DevOps principles and practices, in the IT pro arena is something that I'm quite passionate about, because that automation, that whole, using these tools and technologies to make our day jobs easier. It's not just for software developers. We can start bringing some of this cool tech into our day-to-day lives. So yeah, that's what I do. So yeah, hi everybody. Get your questions ready.
Awesome, John. Awesome, Esther. And we have our last but not least guest and host, Barbara Forbes. So welcome, Barbara, and to everyone out there, what does you do?
Hi, everyone. Yes, I am the Azure Technical Lead at OGD in the Netherlands. I started out as a system administrator long time ago. And already then I was working with PowerShell and automating everything. I've always loved to automate my daily tasks and maybe the tasks that weren't so daily, just because they were a fun challenge. And when I started working with Azure, it was a short way to start working with ARM templates, infrastructure as code, and recently Bicep. And when Azure DevOps and GitHub came along, all these cool technologies we could use to really enhance our jobs, I think. And it's been a few years now, and it's really been a great journey, which I think everyone who touches on Azure or anything like that should invest in, because it's so cool to work with.
Awesome. So we have a special guest as well. This is Sir Titan. He was requested by people in the audience. He's been hanging out for the entire session. He is almost a DevOps expert. He's going to be floating in and out during our Q&A. But more importantly, we have amazing amounts of questions from the audience, and I think it's time we get started. I'm going to go ahead and pick off a random question that I see. So Vincent and I have had a conversation back and forth about the difference of Azure DevOps and GitHub Actions in GitHub. So I think we want to level set to start with and say, Azure DevOps is a very massively mature platform. We've developed it since 2005 as a product at Microsoft, actually 3 years before that. So 2002, 2003, since its inception. And it's been around a really, really long time. There aren't as many features coming out for it because it is so evolved. So we do see security features. We see other things for it. But GitHub is the largest developer community in the planet, right? And everyone goes there, puts open source projects, puts their code there, and it's not mature. It's really not. It doesn't have the same features that Azure DevOps has. So for people out there that are learning the different tooling, I will say there's a video coming out in a couple weeks on Azure DevOps, and it's going to be a 0 to hero video. I might be in it. So take a look at that. And I do have something in the pipeline to talk about GitHub Actions specifically in GitHub, because they're very, very different features. And so Vincent had some great questions about how you set up stages, etc. Completely different. So this is why in Azure DevOps, they moved to a YAML format versus the classic view. And also using your infrastructure as code, your pipelines as code, really everything is code, and it's moving in that direction again. So if you're looking to do stages, etc., you use jobs in GitHub and GitHub Actions. And I think Barbara showed that really well. And if you want to go further, use environments. So if you're not even if you're not deploying to different environments, you can use those as stages. I have an audience question, and I'm going to throw this at anyone who wants to answer it. So question from the audience is, if you're forced to use YAML pipelines and you're not having good productivity amongst your team, is there any visual designer for YAML, especially using Azure pipelines?
Well, I think we kind of saw the assistant that you can use. It's not really visual, but it does create menus for what you are doing. So that can really help. And I have actually seen that people who are working with YAML files, and they had copied them from other people who created YAML files, and they were really struggling with them. And then I showed them the assistant, and they didn't know they could use that. So they were working with YAML for a long time. And the assistant helped with separating the tasks from each other. And I don't think there is one that actually visualizes the whole YAML file, which of course you can create in documentation, or you can check the output of the YAML file, because the output is a visual representation of all the tasks that are done. But the downside is you do have to run it once to see that.
Good. And we have another question about Azure DevOps and GitHub and that kind of what tool to use. Whether people choose using GitHub Actions or Azure DevOps pipelines. And I will say it depends. The biggest reason, it depends is always the answer. If anyone's seen the chat, I've said it depends 100 times, right? If you're in an organization that has data residency requirements, where your data sits, that's always a key thing. Azure DevOps fulfills that. Azure DevOps uses your Azure Active Directory tenant where your company is subscribed to. So I'm going to use the instance of the UK because all of us here, John and I are here in the UK. And because of Brexit, a lot of customers can't have their data leave the UK. So Europe is not an option. So Europe used to be an option, but they've had to move their data back here because of their contracts. So that being said, their Azure tenant, if that makes sense, their overarching subscription, where they're tied to, their billing entity is the UK. That means their data sits in the UK. Whereas with GitHub, that feature is not there yet. So if data residency is a requirement, that's when you should look at GitHub versus Azure DevOps. And that's what I say to any organization. And then the features are very different. And for Esther, I'll pick on you. When you're working with customers and they're asking which way to go, what's some other things that you say to them to look at for features or options?
So for me, it's all about going Azure DevOps when I'm in professional environments. But if I'm playing around with some scripts of my own and playing around even nowadays with GitHub pages and creating my own web page, which is the static, a new one that you generate based on your markup language articles, which I totally love, then I'm definitely relying heavily on GitHub and GitHub Actions, because for me, it still kind of feels like it's easier to share your code with the community from a GitHub repository than when I'm in a professional environment within a company that wants to have more security and more auditing support for their pipelines and automated processes. So then Azure DevOps definitely all the way.
Awesome. John, I have a question for you. We talked about source control a bit, and someone asked a question: when you're dealing with versioning of your base templates, and someone makes a change where that change could affect that template, maybe something for a storage account, etc. How do you deal with versioning of base templates, like your gold standard potentially, right? You have your gold standard image for VMs, because we got a lot of questions actually about state configuration or desired state and config file. So how would you deal with that?
Yeah, absolutely. I mean, there's a number of ways. It's that always that, it depends kind of answer. But I mean, if you've got those kind of gold templates that you kind of want to lock away and keep at a certain state. I mean, look, Git at the end of the day is a version control system. You can kind of tag specific gold images at certain levels and call them, put a tag in there as gold image 1 at a certain level. Now, people can search for those tags using Git. Right? Not sure if it's available in Azure Repos, but certainly in GitHub, you can kind of demark things as, with those tags as your gold version, and you can kind of lock them down. Don't allow people to change things, and if they're at later versions or on different branches, you can kind of keep them. But equally, there's nothing to say that you couldn't lock those things away into storage accounts or keep them in separate repositories. Whether you want to allow people to deploy from them or not, or contribute to them, there's a lot of different variables that go into that. So yeah, just think about how you want to use those kind of gold kind of templates, because essentially if you are going to be hitting version 1 of a particular deployment, do you want to be able to modify that going forward, make it version 1.1, because fundamentally that's what Git's all around. And like I say, you can use that tag functionality to go back to that previous version, but yeah, hopefully that kind of makes a little bit of sense. I don't know if you've got anything to add to that, April.
No, I think you're right. And I think there's been another comment in the chat about are we dependent on vendors to release templates? We're not. Now, I've been on projects where we have to use a specific gold standard VM image because it hits an ISO compliant thing or whatever. It's prepackaged. I've had to do that before. You can absolutely do a lot with vendors and create stuff. They publish. A lot of vendors put stuff into what they call providers. So I'm going to use Terraform as an example. NetApp has a provider that hooks into Terraform. So if you're using on-prem environments or you're in the cloud or both, hybrid, we have customers that are mostly hybrid, to be honest. NetApp has a provider. So whether you're writing a template for on-prem or in Azure, you're going to need to call that NetApp provider, and then they have the modules in which you pull all your code in. So they help with that and what they support. And this has been a discussion around Terraform in and of itself and other infrastructure as code tools, what we call day zero support. So if NetApp releases a new product or a new feature and you can't deploy with infrastructure as code, you can either help them write that provider, you can contribute to it if you really want to, or you have to wait till they release it. Now for Azure, day zero support's available in various infrastructure as code tools. So anything that runs in Azure today, you can deploy with Bicep. You can also deploy with Terraform. There's a new way to do that. Pulumi does it as well. And then some of the other ones I can't answer for the other providers, but those I can explicitly say, yes, they are there. So yeah, it's huge. And going on that, someone asked a question about when do we transition to DevOps? Now, Barbara Esther and John, you have all lived and breathed it. I have as well. Someone talked about, the big investment in time and cost to do it, right? So what point did you find was good for you all in investing into DevOps? For me, a lot of times it's a net new project or a big problem we're trying to solve in our organization. We pick a project and that's where we start it. Now, Esther, you're the first on my right on my screen, so I'll pick on you. What was that trigger point for you to start a project?
Well, I have to be honest that for me, it's been a gradually process. So I started with automating infrastructure deployments, first off using PowerShell to just do the deployments, configurations, mostly focused on end user computing infrastructure components. And then I gradually discovered Github Actions, and it became all of a sudden a transition into what nowadays is called the DevOps engineering role. So I'm not sure where the transition from operations to DevOps actually occurred, if I can pinpoint that in time. But one of the things that I learned joining different DevOps projects within companies is that it's very important to from the start stay aligned with the business processes, because you need them as your sponsors, as your allies as well, to bring in the fun day-to-day tasks or processes that they want to have automated as well, because that gives you a clear goal and a clear setting to start automating and building your own DevOps environment and pipelines.
That's a really good answer. Barbara, do you want to answer that, how that kind of got kicked off for you?
Yeah, I remember the first steps we took with DevOps. They were very, very practical. We were working in a team where we were managing an Azure environment, and this is quite some time ago. And we just found that we had issues because we weren't using DevOps, where DevOps was a solution. So, for example, we were working with Terraform, and we'd deploy stuff locally. And we would find if one person updated their Terraform version and someone else quickly wanted to deploy something, they couldn't do it because they first had to update. And then we found, if we deploy it from Azure DevOps, that we don't have this issue. And another one for the pipelines was also very practical, is that errors make their way into production because we didn't have any automated testing. So we felt a need for automated testing because we saw those errors happening. So that was big motivators, were just issues we ran into. And the same thing when we started using boards, was because we had trouble keeping track of all those changes we had to work through. And the boards helped us organize that. So we went through it in a practical way, just used what we could use at that point and used retros to make sure that we were still on point with our processes and where we would invest. Cool.
I'm actually going to pick on John for this next question. The reason why is I know John has lived and breathed this a little bit, as I have myself. And it falls in line with kind of where we got started. So we have an audience question about someone who's on an ops team working a service desk. Their second line infrastructure for several years, zero experience of development. And if they want to get to DevOps, what course do you recommend they start off with? Now, I'm going to go ahead and start off with this one and say, I'm old, not old, but I'm old enough. I've been in the industry for over 23 years, which is so embarrassing to say out loud. But when I started, things were not in a UI. Like, we didn't have a user interface. It wasn't pointy clicky. There was DOS back in my day. And when I was younger, like learning computers. So we're kind of coming full circle to that. There are DevOps courses of how to lead a team. They're called Scrum Master training, Scrum Master courses. I have a Scrum Master cert, and I actually don't advertise it because I have more experience than the cert gave me, if that makes sense. Certs are great, but experience is even better, I think. It's the same question about having a university degree versus experience, right? You can, but I would say pick some code that interests you and start learning a little bit of how to code. So we talked about YAML, we talked about infrastructure as code. Pick a project, pick a thing, and automate it with a thing. So I would say to people like, maybe PowerShell interests you, especially if you're working in infrastructure. I love PowerShell. You will see me work with the PowerShell team. I worked with PowerShell back in version 2.0 back in many moons ago. So we're going to publish some links. I believe they're in the video and everything, but there's links to Microsoft Learn, free learning resources. So start picking a topic like Git and source control, work through them, and then start picking other topics that really excite you. But find a project that excites you. I started automating things in infrastructure with PowerShell, but then I found things I was like, oh, I could automate this thing. I can automate a server build. And I started leading by example, right? And then my team picked up on it. They're like, oh, she has a point here. I think we're going to listen. But John, for you, what kind of technical learnings? Yeah, it's very, not often people listen to me. But John, what kind of technical learnings really helped you?
I didn't mean to laugh at you, but laugh
yes,
with
you did.
April.
Yes, you did.
No.
Esther. No. Yeah, John, what were some things that you did to learn?
Yeah, so I think, in terms of tech skills, yeah, it's a great question, especially, if you feel you're kind of, that's only making a coffee in the background there. I can hear a lot of noise, but no, I suppose if you're, if you kind of, you feel you're relatively new into this landscape of DevOps, then, just sit there and absorb sessions like this, take it all in. But I think specifically you mentioned that you're in a service desk role. You've been there for 4 or 5 years. So, I'm assuming you've got some kind of scripting or coding knowledge to a point, whether you feel you're mature or a novice, that's kind of by the by. As April says, pick your poison, pick the scripting language of choice. But really good idea, and this is something that a couple of colleagues of mine did, is go back through those service tickets. Get a list of your top 10, your highest rated service tickets. What are they hitting? What problems are you kind of having to constantly solve? Take that and maybe back to that, find yourself a little project and automate it. Pick your top sort of 5 or 10 issues that you've got over a service desk and start to maybe dig into it using some scripting techniques, maybe using a pipeline. And next time you have that particular issue, can you maybe resolve it with a kicking off a pipeline, using some scripting technique? But that's a good way to start. But from me personally, as Esther said, it's been a gradual evolution of skills. And I think it's probably fair to say that's a lot of people's experience moving in, certainly from the operations side into the DevOps, because look, I guess, as a non-developer, we're not, fully au fait with all the kind of the tool sets and features and functionality and the ways of working maybe that software developers have kind of become akin to over the last few decades. For an operations person, a lot of that hasn't been around. So learning that side of the fence has been a huge learning curve for me personally over the last few years. And it doesn't hurt at all to try and, gather those things. But certainly start simple, start with the basics. Don't overwhelm yourself. Any course, Microsoft Learn have got some great things. Pick Git, go and learn a little bit about Git. Have a little look at pipelines. Maybe look into ADO. GitHub have got some fantastic courses, free courses that you can sign up for that take you through the deployment. And actually, as you're reading through the coursework, it takes you through how to use GitHub Actions as you're actually going through. And it's a really great concept. So I'd encourage you to go and look at that as well. But yeah, start small. Find those top 10 tickets, see if you can automate them and make your bosses wow over what you've done for them.
And there's been another comment from someone who's in a team using Team Foundation Server. So it's the older version of Azure DevOps and it's hosted on-prem. And they want to know, how do they get the rest of the team on board? Lead by example, right? Create a project, lead, and do all the amazing things. We talk about developer velocity at Microsoft. It's a phrase that we developed it's a marketing phrase, but how do we enable you to do things better? So maybe start a little project, do a few things and show them what you've done. A lot of times I've worked on teams where we do brown bag sessions, especially in a remote world where we're kind of, really separate from everyone. Take the time over lunch, maybe once a week, and ask each person on the team to do a brown bag session about something they learned. And I'll give an example. I worked on the engineering team at Microsoft deploying out to big customer projects. And we had someone on the team who's a junior engineer. She was a year or so outside of university, really, really bright, but she just learned Git. And even though a lot of us have used Git, we're quite mature in the Git area. She showed how she learned it and things she learned. And I learned from that. So even though she knew Git, a lot of us knew Git, she didn't. But seeing how she learned it, where her pitfalls were great. So running brown bags on your team is a really good way to do that. Just learning experiences. And it could be on any topic. I mean, you could do a brown bag on how I mowed my grass today, right? But maybe keep them a little bit more technical and say, today I learned this thing. I set out learning blocks for myself every week. And I learn stuff every day on my job. That's why we're in tech, right? I want to shift this a little bit to talk about pipelines and actually deploying all the things. We've had a lot of questions about all sorts of things. So a lot of data questions. There's been a lot of questions about data. there's probably some questions. Do any of you want to answer a data question, or do we all want to back out silently? And
Well, I was basically watching the time just a little bit, and I guess this is the right moment to say that unfortunately I cannot make it to the full hour. So yeah, this is me silently backing out of the Q&A, leaving you all there to carry on with the wonderful questions that are out there. And if anyone still has any questions specifically for me and my experiences, feel free to reach out on social media. I'd be happy to link up, ping me, and discover even more fun projects. So thanks for having me, and enjoy the rest of the show.
You and I have matching Grogu's, by the way, Esther. Just mine's not here, but yeah. Awesome. Thank you for joining. Thank you, Esther.
Awesome.
Everyone, please ping Esther if you have any questions. I'm going to throw out a database question because there's been a few database-related questions, but we're going to move into YAML stuff in a minute. How can you use DevOps for continuous deployment integration? Yes, you can. There's a lot of documents on integrating SQL Server explicitly into Azure DevOps, and then pulling out a report and then having that report as an output. I do not specialize in data. I've done a little bit with data, but we have some really good documentation on that. If you can't find the docs or specific data questions, shoot me a message on Twitter or LinkedIn, and I will try to hunt them down for you. I have deployed to database servers and database in Azure Platform as a Service, and it can handle things like redundancy, redeployment. Someone talked about migration. Yes. But give me a shout if you guys need to find the documents. If not, go to docs.microsoft.com, have a look. We do have documents on that. But I wanted to also touch on some deployment stuff. There were questions about configuration of pipelines. So someone asked, why is the YAML syntax different in GitHub versus Azure DevOps? Which one of you wants to take that one?
The why question is dreaded.
Yeah, it's because some person has decided it's a great idea. I think,
Exactly.
yeah, I don't work on the product group. I work with the Azure DevOps product group. But yeah, the YAML's different. The YAML's absolutely different. And a great example of this, I was editing a wiki file for my project, and the YAML was completely different. We have it documented how the YAML formatting is supposed to be. So as Barbara showed you in her demo, you can edit that YAML pipeline in Azure DevOps, and you can use the items in the marketplace, pull them in. That gives you a bit of a visual. It also shows you the syntax in Azure DevOps. I sat there one day writing my wiki article in Visual Studio Code and writing it in YAML, and I had a YAML extension that showed me how to write it, and it kept failing, and I literally banged my head against the desk for like 4 hours. There might have been tears and a lot more tears, but I couldn't find the correct format. I finally found our documentation, but it wasn't apparent because I was using an extension in Visual Studio Code. So maybe do the editing in Azure DevOps if you really struggle with it. But yes, it is different. Also the workflows. This leads into the workflows being different. Barbara, do you want to go into the workflows a little bit and how they're a bit different in terms of like jobs, stages, environments, and all that?
Yeah, there are just little differences, as always. With the naming, it's little differences. With the stages, it's little differences. Like in Azure DevOps, you'll see that you can just start throwing tasks in the window, and you don't have to create a job or a stage for it or a structure at all. And it will be pretty forgiving and will just work. While in GitHub, you do need to use jobs, and you can make multiple jobs to make them into stages. So it's like always, it's almost the same, but a little bit different. That means that on one hand, it's difficult because you need to remember which is which, but on the other hand, you can see the difference pretty quickly. And the good thing is that the naming is different, but a lot of the structures and the things that you need to configure are a lot alike. And I remember I had been using Azure DevOps for some years when Github Actions became a thing. And I decided, okay, well, it's time for me to learn about Github Actions. And that was, I don't want to use the word easy, but if you are already familiar with one of them and you take a few hours to check out the other one, it will make sense very quickly. So you'll be able to catch up a lot faster than if you're just starting out with it.
Absolutely. And I think there's, I actually have an example of a GitHub action on my screen. Do you guys want me to share it? Yeah, sure.
Yes.
I keep random demos on hand. You know, what else do you do with your spare time? So I'm going to go ahead and share my screen for everyone out there. Give me just a minute, and I'll have our wonderful team. Let me see if I can pull it up. Cool. So this is a GitHub action I wrote. I actually talk a lot about this when I talk about security, jobs, and setups. So I have the jobs here on the left. So if I go to my summary page of this action, I can see that I have jobs. So instead of what we called stages, this goes to jobs. And in this specific pipeline, I'm building an image. Doesn't matter if you don't know what an image is, don't worry. I'm basically packaging my application to deploy to anywhere. So this is great because I can actually use this demo to show I'm deploying to different environments, dev, test. I have a staging environment here and I have a production environment. So I'm using multiple facets. So I use jobs to carve out each segment or bubble of what I'm trying to do. So if I click on build and push Docker image, I'm doing all these things in this, what we would have called a stage in Azure DevOps. I am, logging into Azure, logging into my Azure container registry, pushing my container there, and then I'm doing some scanning and getting that feedback. And then once that's done, that means my image is good. It's ready to go. This is like deploying your infrastructure, right? And then I do deploy to Azure. I actually have a step here to deploy my infrastructure. In this specific thing, it deploys via Bicep. So this is my infrastructure stage. Once that is done, I then deploy to a test environment. And the test environment deploys infrastructure to a different environment. It also checks if the infrastructure is there, because we had people asking, how do you check if your infrastructure is there? This one runs a check. It's using Bicep. If the infrastructure is there, it doesn't redeploy. If it needs to deploy it, it can. And if I go to the summary page, you can see, and I apologize, it's a little bit small, that I have put in these stages here where it carves them out. So it gives that little break. And I have my different environments. So I use GitHub environments to delineate my stages, if that makes sense. Think of it like a cake. I have multiple layers in my development cake here. And I use these environments to carve this out. Now, in GitHub, you can do things with environments like set variables and secrets and all that fun stuff. So this relates into what someone was asking. How do I put in checks or manual checks? So in this one, we can see I have a review deployment here on the right-hand side. This means that I can't proceed without a manual check. In Azure DevOps itself, you can do this. You can also do timed triggers. So say maybe a lot of people actually in the chat said, I can't deploy out of hours, or it has to be out of hours because of our SLA to our customers. Okay, cool. So you can put in a triggered time that might deploy at after 6 p.m., right? You can put some limitations. So this one takes a physical review for me. This might just make sure this is a visual check. Is my pipeline all green? I check all my monitoring, etc. Yep, I can go, and then I can approve and deploy to my next environment. And I can literally click the green button, and you can see that it's going to start deploying to my staging environment here. So you can see it started, and to be honest, I may have used this previously, but I can see my staging environment, and it's going to start running this job. So I can put in those manual checks, and you can do the same thing in Azure DevOps as well. So you have those abilities. Someone talked about, I'm trying to find it, sorry. How do I go about fixing bad deployments? Oh, sorry, dog. You can reconfigure your deployments. So, instead of, I guess John, I'll let you take this one because you love ARM templates. Just kidding.
I think it's one of those great questions, isn't it? Because I'm pretty sure, if we're all honest with ourselves, we always have a bad deployment. The first time that we try and create anything into using pipelines. But I mean, depending on what you mean. Let me just read that. I have issues where a lot of deployments can be done with no networking considerations. How can I add fixes in the portal and export the ARM template? Yeah, I guess it's one of those things. I think that the point with ARM particularly is that essentially it's I can never say the word. It begins with I, and I never get it right. What is it, April? I can never say it properly. But essentially, you've got to get this concept in your mind that when you deploy something with an ARM template or a Bicep file, whatever it might be, do you want to do changes to that afterwards? Because typically speaking, you might not want to use an ARM template to do that. What kind of changes do you want to do afterwards? Files like scripting languages and tools like Terraform and things like that hold state. So they'll hold what you've just deployed in a state file that could be stored in a central location. So then you can use that Terraform or that particular thing, or Pulumi, whatever it might be, to go and change those things afterwards. So yeah, when it comes to ARM templates, it's probably not the best example. Typically, an ARM template in my world, I would use to deploy once, many times. So I've got that ARM template that I can use to deploy that environment multiple times, rather than then going and modifying or tweaking that, albeit through the portal or through the ARM template, because you kind of need to start again, if you do tweaks through the portal. Whereas with something like Terraform or a different approach, if you're using state for when you deploy your infrastructure, then in theory, dependent on what infrastructure you've just deployed, you can use that state to then modify and change that, and redeploy that using pipelines so that it modifies your state and the infrastructure in a cloud platform. That's the way that I would see. But he needs to write back to a repo, write back repo as updating it to manual. I guess that's what they're saying, is that they're updating that manually through a portal. Yeah, absolutely. So I guess they're making a change in the portal, updating their code in the repository as though they've just done that. Yeah, that's not a great place to be. You want to try and avoid that if at all possible. I think that the reality is, if you've got infrastructure that's long-running infrastructure that may be there supporting an application or whatever, you've either got to take the approach of trying to deploy the application on that infrastructure in a, it's this pets versus cattle mode. April, you love talking about it, but this mode of, I don't really care what infrastructure, so I can redeploy the whole thing every time I do an update. But then that has implications on how long something might take to redeploy. So you've got a lot of these different variables floating around based on what your actual context is and what you're trying to do. So if you're trying to just deploy something once quickly to get yourselves up and running really quickly without the need to go through a portal and introduce errors into naming conventions, ARM templates all the way, bicep files, whatever it might be. If you want to then subsequently change that at a later date, then you're in the realm of having a really complicated mechanism for keeping those updates in check, or you just choose, something like Terraform, Pulumi, another mechanism to deploy your code that keeps the state. It knows what you've just deployed and it knows the state of that deployment. And I guess we're into that conversation of deploying infrastructure versus configuration of that infrastructure. So yeah, there's a whole, I suppose, gray area in that space. And the way that I kind of work through that is I didn't look at this as one giant picture, as though, I've got this super set of infrastructure that I'm deploying. I want to manage it all through a single repository. Try and break things apart. Try and space them out into maybe multiple repositories, or start with something relatively easy to manipulate, so you can start to build up your skills, and you know how these things are going to interact with each other in your solution, because you start making a change in one repository and all of a sudden that one repository is deploying a whole heap of stuff. Probably not the best place to be. Try and break that down into simple, easier to manage chunks. And the example I tend to use is either, Azure policy, manage a policy in a repository, or maybe things like firewall rules. If you've got to update Azure firewalls on a relatively regular basis, it's a typical operations thing that we have to do. One of the reasons behind firewalls is always a good point, is that there's no backup of your firewall rules once you put it in there. So why not put it in a repo, put it in an Excel spreadsheet, or something a little bit more
and you can create a pipeline just for that, right? So if that goes down, you can redeploy and have your code sitting somewhere. There's a lot of questions about repositories, configuration, how to configure a repository. So when we look at the structure of Azure DevOps, we have a project, and each project should probably, someone asked about, having multiple customers deploy. A lot of times when I've worked on the MSP side, coming from before Microsoft, we put different customers into different projects. So we had segmentation of data. But it depends, right? Are you deploying the same thing to the same subscriptions, et cetera? But a lot of times for customer projects, we have them in their own project itself. That gave delineation to the customer data as well. If they had any customer specific data going on, that gave that delineation. So you do have to see what's in the contracts, et cetera. In terms of best practice, that's probably a good way to do it, unless there's some other limitation. And then, creating repositories. It's always, people ask how many repositories, how many pipelines do I have? It's always important to think about what you're deploying to, how many projects, et cetera. And someone asked a question about having resource groups, multiple resource groups. Do I have a project per resource group or a pipeline per resource group? And probably not. That's a lot, unless you have like 100 resources in that resource group. But I would call that a project or an application stack effectively. So what dependencies are you deploying to? That should be your project. There was a question about, where was it? Sorry, I'm losing it all. Barbara, I'll ask you one about SRE and DevOps, how they coexist. What's your opinion on how they should coexist in an organization?
Which was the first one? What's SRE?
How do SRE and DevOps coexist as part of an infra standards implementation?
What's SRE stands for?
Site reliability engineering. So you're monitoring. So I'll go ahead and take this one.
Yeah.
Yeah, a lot of times people talk about SRE and DevOps and how they intertwine. SRE is part of the DevOps lifecycle. In the DevOps lifecycle, we plan, we develop, we deliver, and then we monitor as part of our production systems. And SRE really handles that monitoring side. So bringing them into the full lifecycle is really, really critical, because that feedback that SRE gets for monitoring helps us deliver and plan our next cycle. So SRE should absolutely be part of the lifecycle. The DevOps team shouldn't work independently. So a lot of times we see the SRE team as part of the DevOps team as well. And I think a bigger thing is, and I think both Barbara and John and myself can talk about this, is having cross-functional teams. So in an infrastructure stack, that might be, let's say there's people out there I know that comment on being, network specialists on this event. And your networking team should not be your DevOps team. And actually, I'll bring up a visual in a couple minutes. I can show everyone of what a vertical stack looks like in the infrastructure space. But effectively, we want vertical or T-shaped engineers because you have empathy for the other stack. I mean, let's say you work in networking, you mistype an IP address and you bring an entire network down. We've seen it all the time, like way too much probably. And how do we then, recover from that? And you kind of say as networking, you throw the blame over even just the infrastructure fence, and we don't want to really do that. So let's see, John, I will ask you to answer the next question while I pull up my little slide bit. What's the best automation you've ever done in your career, and why?
Oh, wow. Yeah. How long we got? We've only got half hour left, haven't we? So I think from an automation point of view, this was a little while ago, and I guess terms like DevOps and things like that were around, but they were in their traditional sense of lean manufacturing. So I was working at a manufacturing company at the time, and it was all about a process flow. So the line was written out for me. It was a manual physical operation where you had flows with people working at stations doing tasks and signing things off on a paper copy. So not just digitizing that, and like I say, this was a number of years ago, but I'm pretty proud of where it got to in that sense. The automation of those tasks was a great thing to move into. So pipelines essentially for every station that was there. So anytime an operator did something for a particular built a physical thing that they made, they could just do that electronically and it would move on to the next stage. Once all the stages were complete, essentially that built up what we now call today a pipeline, and it triggered off the set. Essentially, everything that was being built in that pipeline came with a wad of paper about that thick, and customers would order sort of 20 of these things in one go. So, part of the customer pack that would be given to them would be a couple of reams of A4 paper. And what they would do is go back and they would give that ream of paper to an office junior who would stand at a photocopier for 2 or 3 hours to photocopy them, because you can imagine all these papers were covered in ink and dust and muck and things like that. So essentially this process took all of those electronic operations, put it through the pipeline, and essentially compiled them all. And using pipelines, and again, this is the kind of thing that you can kind of use pipelines for today, built that up. They built it up as a PDF just through a simple script function. It grabbed all the electronic information, pulled it into a PDF, generated that PDF with a nice neat table of contents, spat it out the other side ready, an artifact out the other side ready to deliver to the customer. So that was a little while back. Really proud of that one. But yeah, these are the kind of things that we can start to use our minds to kind of start to do now for the benefit of our organization. So it's the tangible world meeting the digital world, I guess.
I love it. I'm going to go ahead and show everyone the vertical slide, because everyone I like a picture. So if you don't like a picture, I'm sorry, I love a picture, right? So we look at vertical operations. So if you're on a team that's networking focused or storage focused or hypervisor focused, it's about thinking about how that affects the stack. Now, I think we all know when we're building out any kind of VM or hypervisor, there's networking involved and there's storage involved, but we have these dedicated teams in infrastructure. So we talk about bring down the silos between developers and operations. We also need to think about in operations how we disintegrate our silos, because there's always a blame game when there's an outage, and we're going to have an outage. So that's something to really think about. There's a lot of questions about infrastructure as code coming up. So I do want to actually make sure we get to those, because there's some great questions. Barbara, there's some great questions about using Bicep versus Terraform versus ARM. There's a lot of questions that people have. Let me pull some up here. Here we go. There's one about using Terraform with a single pipeline. They're thinking about using to Bicep, splitting by resource groups, and maybe how to set that up. I mean, I think people want to know, do they go to Bicep? There's also questions about like when they go to Bicep. Should they? When to use it? So I guess it's kind of like a 3-part question for you.
Yeah, that's a lot of questions at once. The most simple one first. If you are using ARM templates right now, try Bicep. Because Bicep is the same technology as ARM templates. It's a wrapper around ARM templates, but it actually makes your life easier. Because biceps are created in JSON, and JSON was meant for machines, not for humans. So there's a lot of stuff going on if you create JSON files. And it's actually pretty hard to create flexibility with ARM templates. And that's something that you want to do because you want to create one template that could rule them all, right? So you want not to copy much of your code and create a lot of files. This becomes easier with Bicep. Bicep is simpler as it's written. There's a great extension if you're using Visual Studio Code. If you want to get into it, it can almost write those Bicep files for you by themselves. And it's really better to work with than ARM templates are. It's created by the same team, and in the background, it's using the same technology. Now, the funny thing is, if you are familiar with Terraform and you start using Bicep, you will see a lot of similarities. So let's say it took the best of both worlds and put them together. If you are focused on Azure, I think that's an important part. An important thing that Terraform does that Bicep doesn't do is multi-cloud environments or hybrid environments. Bicep is only for Azure. Then again, it will be quicker if you're working with Azure because it's part of the technology itself. So it uses the APIs a lot faster. It is a development that's going on. And I think John and I can have a long discussion about the state file because I am not a fan and I heard that John is. And we say when we're using Bicep that Azure itself is the state file, actually. But yeah, I think we can have a long discussion. Really, it's a personal preference. And I just heard we don't have a long time. So before John and I need to get into a fight between Bicep and Terraform, there's a lot of personal preferences in there. But I will say if you are using ARM templates, you should try Bicep. And if you want to try Bicep, haven't worked with it before, you can check out Microsoft Learn because there are extensive Learn modules on it. You can actually check out Learn TV, and I think the link was somewhere in the chat where with a bunch of people from Microsoft, they did videos on every course on that Microsoft learning path. So there's a lot of resources to actually get started with this.
Yes, and there is a blog I'm going to put in the chat for everyone. Bear with me. I'm trying to look it up with the dog on my arm who weighs 69 kilos. There's a blog out there that I wrote comparing the infrastructure as code tools. We don't have enough time to talk about all the tools, but it does compare them, all the pros and cons. It talks about Ansible as well. Yeah, I think that's a great thing. There are lots of great questions in here. I know we need to be conscious of time, so I'm going to try and get through a few of these. Someone asked a question about if you don't know Git today, should I learn it? Absolutely. Yes. Git is the foundation, right? It's like we're building a house, and we're going to build our house, and we can be like the 3 little pigs. We can build it out of straw and learn some of the toolings, but then like Azure DevOps, we can learn GitHub. But if we don't learn how Git works, you're not going to be able to check in your code or your files or anything. And Git is a finicky beast. It is very much a finicky beast. So learning how to use it is absolutely critical. So there is a learn path. I believe I posted earlier, but we can probably find it for you to learn. So if you go to learn.microsoft.com, type in Git, there will be a resource page for today. So it is in there. There's a full learning path on DevOps and it includes the Git stuff. So yes, absolutely. We want to build a solid foundation of our house. We want to make it out of like really good concrete, not straw. So learning those things before you can go into the other tooling will help you massively. Otherwise, you'll get into the tooling and go, I don't understand how to clone this code. I don't understand the repository thing. I don't understand all these things that are hard. And that's okay. I still fight Git to this day, like all the time. And I'm still learning new things in Git, new commands, new things to do.
I think no one honestly completely understands Git. I think there's always stuff you don't understand or stuff you have to Google how to get yourself out of information. So I saw a thread online about that, where all these programmers were like, we know how to get around in Git. And when stuff goes wrong, we need to Google how to save ourselves from our situation. So it can be a very intimidating tool because there's so much going on. So I would recommend just start small, start with the basic stuff, start using it daily for your scripts, and you will find your way in it, and you will be thankful every day that you learned how to use Git.
Absolutely. And I think a lot of people are asking very much where to start. So I think it depends on what you're doing. And one person says, I work on a service desk. John said it, find a ticket that is a regular problematic ticket. How can you automate it using even something as simple as PowerShell, et cetera? If there's infrastructure you're constantly deploying, maybe get a service desk ticket in to deploy a new VM, which happens a lot, or a new service. Try looking at infrastructure as code. So find that thing. And a lot of people ask what language to start in. Now, that's tough because, again, if we're not doing it every day, we need to know where to start. So find what you're doing in the tool that best fits. So if you're in the ops space, PowerShell is a great tool. If you're working in Azure, Bicep is a great tool. Think about what things you do. When I learned Terraform is based on Golang, which is a language that developers use. It's not as widely used, but if you work with containers and Terraform, Golang is massively, massively useful. So I started learning Golang as an actual programming language. I am in no way, shape, or form a very good programmer, but I know enough to do what I need to do with containers. I understand the structure of it. And these are all things we have on Microsoft Learn for you to go. So in terms of like learning Terraform and GitHub, I think these are different entities, right? GitHub is the storage of Git. So it's a service for Git. So the way I think of it is Netflix. You can have a DVD and that's the equivalent of your Git. But Netflix is a storage of all the movies, right? Effectively. So it's kind of the Netflix of DVDs. So Git holds GitHub. GitHub holds Git, right? It's just another Git tooling. There are other tools out there called GitLab. The reason why we're using GitHub today is because it is the largest platform. It's free. You don't need a license for it. You'll need an enterprise license. And if you're searching for projects that interest you, go to GitHub and search because people post the stuff as open source or free to share with you in the community. So if you have a personal project you want to get started on, GitHub is a great place to go. John, Barbara, any suggestions on languages from your side?
No, you've said it, April. I think find your happy place. I think everybody's going to be different and there's no right or wrong answer there. I think it's literally, yeah, if you're in the ops space, you're an IT pro, odds on if you're working a lot with Windows servers, you're going to be doing, a little bit with PowerShell. If you're in the Linux space, go and learn Linux. I can't, kind of throw that out there enough, especially if you're looking to go into, DevOps and pipelines. At the end of the day, you might want to use, or you probably will be, let's face it, the cloud's built on Linux. Yeah, did I just say that? But it is, at the end of the day, if you're using Linux essentially to script, to run things, I think Barbara, you pointed out in your demo there are slight nuances, that you're going to get around if you're used to using command line tools, but // / command line tools that you can use to do things with, and there are ways and means. So yeah, go and learn Linux, go and get some cloud fundamentals, absolutely, because we're talking about cloud platforms, one would imagine today. And yeah, find your happy place. But yeah, don't let anybody tell you picked the wrong language, basically, because you probably haven't. It's suitable for you. Absolutely.
Barbara, did you put in some sample code in the repository for testing and deployment with Bicep? I can't remember.
Yeah, yes, I did add some code so people can just get that. And well, I would say try your own code. And if you run into problems, then check my code if it maybe helps you.
Absolutely. And I think, there's questions about debugging and testing scenarios in a pipeline. It depends what you're trying to debug and test. We use a lot of unit tests in the engineering side of Microsoft, unit tests galore. The Azure DevOps product team runs over 50,000 unit tests for each pull request, and they run them in about 5 to 8 minutes. I had a screenshot of it. I don't have it on me now, but I used to show the testing protocols that the team used. It was pretty cool. But Barbara has some sample code for Bicep, some testing. People asked about like sample Terraform, etc. I have some videos on the DevOps Lab from 3 years ago. It is a bit older, still very valid, but my Terraform code itself isn't up to date. So it's an older version. I think it's version 1.12 or 1.14 maybe. But there's a GitHub repo where there are Terraform templates available for you. I don't have the link of the repo offhand, but it's if you Google GitHub, Terraform, Azure, you will find a repository with a ton of scripts. There's also, that's probably the best place to go. So between my videos, my blog, and then the GitHub stuff, it's all open source, all available for you all to see. People have sample code everywhere. Same thing with Bicep. If you want to get started with Bicep, all the Bicep code is available on GitHub that you can go in and look as well. So I am conscious we're running out of time, but before we start wrapping things up, I do want to ask Barbara, what was the coolest thing she's automated?
Well, actually, I can tell you about a project I did this weekend, because I had a very busy weekend. So I tried to thought I need to relax. And when I need to relax, I'm going to create some code, because that's what I do. And I needed to make some sort of a lab environment within my own Azure tenant. And I actually created it completely with Bicep and PowerShell, where I can set the number of students that I have for a course, and it will create a resource group for each of one. In the resource group will be a virtual machine, because we're going to practice with an Azure DevOps agent. And it will create both a user for that resource group and a service principal, and both of them will get the right permissions, so the owner permissions to their specific resource group. And in the end, it will create a file with all the credentials that the students need and all the information about it. So when I give courses, that's going to save me a lot of time.
That's awesome. And I know someone just pointed out that I used the phrase Google instead of search engine. Yes, go to your favorite search engine and look these things up. Sorry. Yeah, you can tell which one I prefer, but it's all personal preference. I do use Bing, for the record. I just don't use it all the time. So I just want to rehash on everything we've gone over today. So this recording will be available for everyone to watch after. We have lots of resources for you all. Learn modules, learning paths to learn Git, source control, etc. in Azure DevOps, how to get started on Azure DevOps. You can watch the DevOps Lab. We're going to have all sorts of videos coming out. For everyone watching today for Azure DevOps, there's a video coming out in 2 weeks. That's going to be a 0 to hero video. Can't say who's going to be starring in it, but it's myself and another amazing community member. So we do gear it for literally everyone. And the other person in the video does talk about some YAML, how to write YAML, and they code it live, if you will. I mean, it was recorded, but live. So it will help you do that. So just want to thank everyone for joining today. We're going to have links going out for you all to reference. And again, any questions after today's session, please feel free to ping these amazing people: John Lunn, Barbara Forbes, and Esther Bartel. They're all available on LinkedIn and Twitter. Please follow. They constantly write amazing blogs. They do great stuff as MVPs in the community. But most importantly, I want to thank you all for delivering this content today to the community. And we've had a lot of viewers, a lot of amazing questions. So thank you for everything.
Well, thanks for having me on. Yeah, it's been fun. Thanks everybody for watching.
Yeah.